we don't waste so much time on it, because time is actually of the essence for us in this class. Um, so, and while I do that, Emmanuel is going to be taking the practical session for this class. So he will also be preparing his environment so that he'll be able to take us through the class for today. He's our expert in that area. Okay, so yes, yeah. Yeah. So Temilola, say hello to us now. You don't want to say hello to us. Temilola, are you on the line?
Hello. Yeah, I'm here.
Okay, nice one. Thank you. Okay, so last week we spent time to introduce us to the concept of big data. What exactly is big data all about? We also talk about the history of big data, how it has evolved from what it used to be to what it is currently, and some of those things that have driven the evolution of big data. There are new technologies, there are new devices. The phone that a lot of us have, it's more powerful than the most powerful computer in like the 80s, and it's not a common phenomenon. It's not even like it's just some people that have it, it's almost everybody that has it. We also talk about the different types of big data. There were different ways we looked at the different types of big data. Some of them in terms of structured or unstructured, some of them in terms of the sources, in the sources where the data itself is generated. Some of them is in types of the kind of operation that is performed on it. Then we also talk about the elements of big data. What are those things that constitute big data? Then we also talk about the applications of big data across different industries, insurance, oil and gas, banking. In regulatory, there's always application of big data across different sectors. You can always think about something where you can apply big data. This morning before I came into this call, I was having a chat with my colleague in the office, and she just came up with, listen, maybe we should do something like hush puppy analytics. What she's trying to say is that, okay, internet fraud. So internet fraud, can we do some analytics around internet fraud? So instead of just calling it internet fraud analytics, she decided to name it hush puppy analytics because it's kind of a trending topic. The fact is that for those internet fraud that is happening over, the email scam, the fact is that if significant investment is channeled into those areas, some of those things we'll be able to nip some of those things in the bud. Then we also identify some of the careers where big data is applicable. When we talk about data engineering, data analyst, and data scientists, those are some of the things that we discussed. We discussed last week. We spent a lot of time to talk about structured data and unstructured data, and also the fact that data, when big data is big data, then it's either voluminous or the rate of change is very fast, or it's also the fact that it comes in varieties, and you have a lot of that in telco, in banking, in energy sector, in the social media space, and the rest of them. Then I think we closed last week talking about the technologies for handling big data, where we introduced the concept of parallel computing. Yeah, the concept of parallel computing and distributed computing. So the way I was able to explain the concept of parallel computing is that, so when it is before now, when it was not distributed computing, jobs are submitted on a PC, on a computer, and the job is done as a batch process in terms of the first step is still done, the first job is completed, then the next job is done, then the next job is done, then the next job is done. So in that case, if there's an error on the first job, they will need to stop the whole process, fix the error, and then continue. So every other person down the line will be at the mercy of the job that is currently operating. So they decide to rethink about how to redesign computer in such a way that there could be many interconnected computers within a network. They're interconnected, they're interdependent in such a way that when a job comes, the job can be split into smaller chunks and then is distributed across all of these different entities that make up the network. So once it is distributed within those entities, the job is executed. After the job is completed, then there's another process that combines all the results together into the final output that is needed. So can we distribute the resources? So rather than having only one processor that is executing this job and only one memory that is executing this job, can we have multiple processors and memories connected together? A bit technical. It's technical, but really that is actually what makes Yahoo and Google. That is what makes it work. That you go to Google and you search for an item in Google, and it can return like 5 million. It will return like 5 million results. So when you do a simple Google search, like I want to search for, say, what do I want to search for now? Say I want to search for, say, a word like revenue. Yeah, I just want to search for a simple word like revenue. Google returned about 723. So on my screen now there is 723 million results. So how is Google able to return 723 million results in a very short in a microsecond, in 0.61 seconds? So I did a Google search now, and I searched for revenue, and Google returns 723 million results in less than 1 second. How is it able to do it? It's based on how all the text. Dr. Aben, you are welcome.
Thank you. Good morning.
Yeah, good morning, sir. Okay, so we are just having a recap of some of these things that we did last week. Okay, so as I was saying, how it is that Google is able to search for millions of records, So maybe you too can just open a browser on your PC and search for revenue, in the browser of your PC and see the results. It returns about 722 million results in 0.61 seconds. For Google to be able to do that, then there must be a way of organizing and structuring those data, for that result to be able to, for the search result to come out very quickly and to return so many results. It's actually the concept of distributed computing that makes all of that possible. Actually, it's the internet companies that actually started the concept of big data. So when they started it, and they have used it for a very long time, Yahoo, Google, after they've used it for a very long time, they now decided to release it to the public to be able to adopt the concept. So some of those things we discussed last week, where we look at the architecture of big data or of distributed computing. We look at the architecture of distributed computing. We also talk about the architecture of parallel computing. So in parallel computing, there are many processors that are feeding on one single memory. In distributed computing, there are independent processors and memory. A processor and a memory altogether, they are the core components. They are the central processing units of a computer. Those are the core components of a PC. So when you have a processor and a memory, you like almost have a computer there. So in distributed computing, all of these are connected in a way that that makes job execution a lot faster. So so yes, so this should lead us to a uh, particular technology that is called Hadoop. This should lead us to a particular technology that is called Hadoop technology. So the way that Hadoop technology, the way it works is, um, it leverages the concept of distributed computing, and it's made up of three key components. One of them is what is called HDFS, the file system. The other one is called the map reduce function, and the third part is what is called YARN. It's called Hadoop. So there's Hadoop, there's map reduce, and there's HDFS. So if in your exam they ask you about some of the components of Hadoop elements, or they may ask questions like, okay, which of these components of Hadoop is responsible for maybe a particular operation? You need to be able to understand that. But before we get into some of those details, I will want Emmanuel to even take us through the virtual lab environment. Let's even see how to navigate through the virtual lab environment. How do you how do you run commands? Some of the commands that we are going to run, how do you relate within the virtual lab environment? Um, Emmanuel is going to be leading us in that session, the practical session. So I just want to check with Emmanuel. Emmanuel, are you ready for us, or we should give you some more time?
Good morning, sir. I'm ready, sir.
Okay, so over to you.
So good morning, everyone.
Good morning, Emmanuel.
All right. So I believe in more than 80% of participants here have the virtual lab environment on their PC.
I have it on my PC, but because I am in transit, I don't have my laptop here.
Okay. I think. How about Temitayo? Have you installed it yet? I'm sorry, Temilola rather. Temilola, are you with us? Oh, I think Temilola, we lost Temilola. So we are going to open the virtual lab environment now. So I'll be sharing my screen. Okay. I believe I'm sharing my screen now. So this is the VMware workstation. So I'll double click it.
Sorry, Emmanuel, I can't see your screen.
Oh, you can't see my screen. Wow.
Yes.
I will share it. If you can see my
Maybe
screen,
I can't see it. Maybe other participants can confirm. Probably the problem is from
okay,
my end.
Okay, it's back now.
All right.
I can see your desktop, but the voice breaks. I don't know whether it's from my end.
Maybe it's the network. The network on my end.
Okay.
I can see your screen. All right, I'm going to. Okay, this is my workstation, so I'll just double click it to open it. Then, so it's going to show me this. I believe it's showing this right on your screen.
Yeah, I can see your VMware.
So I'll just open the file to run the virtual machine. Then I'll click on play virtual machine. So I'll just OK this. So I'll just click on remind me. Any updates notification you get, just click on remind me later, or ask me later, any which one. So for this lab session, we'll be logging into the HD user. We'll be logging into HD user, and the password is still HD user, lowercase. Then I click on enter. So I'll just click on ask me later. So you should have this kind of environment. You should have this kind of environment if you have done those steps. Are we on the same page?
Yeah.
Okay. Any other person that is on the same page with us?
Yes, I am.
I am.
Oh, all right, good. So this first application here is like your search button in your Windows environment. This is the Linux environment. So probably I want to search for a file or an application. Maybe I want to search for House Studio. I'll just click on this guy. Then I'll just type House Studio. Then it's just bring House Studio. Then I'll just click on House Studio. Or maybe I want to say something like, let me see. I'm trying to say ability. There's the file name called ability.txt. So this is the file. I can just do this. And how your start button works in Windows. So that's what this guy does. So now we have this file. This is like your file explorer. And this is the House Studio application in Firefox, and it's just like another computer on another computer entirely. So let's see how to run some Linux command. So to run Linux command, you go to your terminal, just like your command prompt in Windows. So let's open the Ubuntu terminal. So if I should open the Ubuntu terminal, I'll have this environment.
So what are you running?
Linux command. Linux.
Oh, okay.
Yes. So do we have this environment like this? No.
Do you want us to be doing it as you're saying it?
We are following you. We are not doing it.
Like,
which one, do you want us to be doing it as you're saying it, or just watch you and do it later?
Yes. You should follow me. That's why you're opening a virtual environment. You just follow me as I'm doing it, and
I thought we'll be following you first.
And you see what I did, then you repeat it at your own end too.
Later or at the same time?
Hello, which one will be better? That we follow you first?
Okay, since you are seeing my screen and you're able to open your virtual lab environment at the same time, are you able to do that at the same time?
Okay.
I am here to open mine.
Okay, if you can't follow us at the same time, then you can just get a pen. Though everything I'm doing is inside your lab workbook, inside your material. So you can just follow up and see how it works, then get to it later too. And if you can follow me at the same time, that also works. So probably if I want to see the current working directory I am in this environment now, it's just like I want to see where all the commands or all the thing I want to do in this environment, where all those files are going to be saved is called my working directory. So if I want to see my current working directory, I'll just use this command pwd. I'll type pwd, which means print current working directory. So if I should enter, it's going to give me my current working directory, which is home/hd user. So this is where my current my working directory is like this. So that's what this command is doing, pwd. Do you understand what I'm saying?
Yeah.
All right. So if I want to see, maybe I want to see the files or directories or the folders that I have in this working directory, the command I used to run that is what we call ls. Then I can say ls.al. That is list all files and directories in this current working directory. And I'll see this guy. So I have these files and folders. So I have ability1.txt in this directory. I have this zip file. I have this directory, this directory, this directory, this directory, and all. This is all I have in this working directory.
Hello,
So
Emmanuel.
Hello, sir.
Please, I just want to call your attention to something. So out of the 3 textbooks that you gave to us, which of the 3 textbooks should we like make reference to? So that some of these things that you are doing, we can also reference them in the text. Which of the 3?
Okay, you have 3 textbooks. You have book 1 and book 2. Then you have your workbook. So from your workbook, you can reference your workbook for this this particular session.
Okay, thank you.
That's your big data analytics lab.
And I want to appeal that you take it a little slower and more rudimentary, because this goes like programming and the writing of equations. Help us to understand what you are doing. That's why, for me, I'm not opening my Hadoop. I'm just looking at you first. Okay, because working hand in hand at the same time will not enable me to follow up, because you'll be in the next thing while I'm still behind trying to figure out what to do.
Okay, sir. So
I'm not opening mine, I'm following you. So
this first line of code I just wrote, pwd, is to print the working directory. That is the folder whereby every actions I'm taking in this environment, where those files is going to be saved. So this is the folder to print it, home/sd user. So anything I'm doing in this environment is going to be saved in this folder. So that's what this guy is doing. So the second statement here, which is ls-al, is to list the files and directory that are in this current working directory.
Okay.
So these are the folders and the files that we have inside. Now, for example, I can take this department.csv file now. Can you see this department.csv file that I'm pointing to?
Where is it?
So if I want to see this, where my cursor is, this is my cursor. Can you see my cursor?
Okay, yeah.
So if I want to see what is inside this departments.csv file, what is the command I can use to do that? So I'm going to use the command what we call cat. Then I'll type the file I want to see. So I'll just do that in the next line here. This line that is downward here. So I'll type cat. Then I'll type the file, which is departments.csv. So if I should enter, I should be able to see the contents. So this is the content of what's inside the file. We have department ID, department name, manager ID, location ID, then administration, like in an Excel kind of format. Can you see this?
We can.
Okay, so do we understand what the code is doing?
What is the meaning of CAT?
So CAT is just to print the content of the stated file that is inside file. So CAT means print, then department.csv. So print the content of the department.csv. Okay. So do we get it now? Do we get it?
Yes.
Okay. So I might want to change my current working directory. I might want to change it maybe to desktop. So what's the code to change it? CD. C and D, which means change directory. cd means change directory. So I will now specify the path, the directory I want to change it to. So that will be home/hd user, then /desktop. This is the, so I want to change my working directory to desktop now instead of home/hd user. It's just like in your Windows where you have your you write C, then a colon / maybe desktop or download and specifying the path. So this is just the path. Then you're telling to change directory to this path. So if I should run enter now, if I should click on enter, so it has changed to desktop. Can you see that it's on desktop now? Can you see that the directory has changed to desktop in the next line of code?
Yes.
Desktop and directory. When do we use directory? When do we use desktop?
No. Your question is not. So I'm just saying that you might want to change where your file should be saved. The current directory was home/. Yes, exactly.
Okay.
So you might want to change it. So I just changed from that particular directory to desktop directory.
The desktop. That's assuming that your files are located on your desktop.
Exactly.
It's
Let
okay.
me zoom in so that.
It's okay.
So that you can see.
I think it's better this way.
Okay. All right. So okay, let me see. If I want to see the contents I have in the desktop directory, I'll just use this command, the ls.al, ls-al command, the same command I ran that time. I can do that. So what are the contents I have in this desktop? These are the contents I have there. Now you are not limited to just what you have in the current directory. You can also list what you have in another directory, but you have to specify the path. See, this is what I'm saying. You know what I just did now in this case, it just gave me the directory and the files in my current working directory, which is just desktop. Suppose what I want to see, suppose I want to see what is inside another folder entirely, which is not my current working directory. Let's say the datasets folder. Let me check my files here. Look at files now. Maybe I want to see what is inside this particular folder. Let's say where is it? Let's say this folder, datasets. Can you see this datasets folder? Suppose I want to see what is inside. I'll just come here. I'll say ls.al. Then I'll specify the path home/hd user. Then / the name of the file is datasets. If I'm not wrong, let me check again whether it's dataset or datasets. Okay, there's S, datasets. So I'll put S. So this should be able to list the files that are in this dataset folder and the directory. So look at it now. So it has listed what I have in the datasets folder, which are all these guys. Can we see this?
I have a question.
Okay.
So basically, instead of LSAL, can't we just use LS?
Yes, you can use LS. You can use LS.
No,
use LS.
instead of LS-AL, LL will
Yes.
also give us the same output with shorter.
So let's see what LS. Let's see what LS will give us.
LL, not
okay.
LL.
Okay, LL.
Yeah, LL will give you the same output.
Okay. So LL should give me, if I should type LL like this, it should give me all the files and directory I have in this current directory.
Including special files, yeah.
Okay, yeah. Let's see. So you can see also that this guy gave us the same the same result as this guy gave us ls.al too. So good one from Demilola. So it doesn't matter. It doesn't matter. It's just to achieve the same result. So are we following? Are we still following?
Well, hello, Iman.
Hello, sir.
Yes, sir. Like we said earlier on when we started last week,
Yes,
don't assume anything, because most of us, or I should speak for myself, I'm being exposed to this environment for the first time.
Okay,
So
sir.
it will not be easy for me to run at the speed you are running. For instance, when you write desktop and you add a $sign, is it automatic, or would you just add it yourself? What is the role of that $sign?
No, I didn't add the $sign. The thing is that in some environments, this dollar, instead of dollar, you just put a greater than sign. So it's just like it's showing that this is the beginning of the code is automatic, is added automatically. So this is your working directory, and this one just come automatically. It's not that I added the $sign. So look at it now. I think it came. Look at this last time. It just came with it. So in some environments, you might just see arrow key. Let me open the command prompt for you in the Windows environment. Let me go to the Windows environment and show you something. So if I go to Windows and type cmd, look at it. It's showing you user Octave Analytics PC2. So this is my directory. Then you have this greater than sign.
Okay.
So this is the Windows environment. Or in the Linux environment, you have $sign instead of this sign.
So once you type the desktop, the sign automatically attaches itself because of the environment.
Yes, sir.
Okay.
All right.
Okay.
Okay. I can also do a search. Maybe in my current working directory, I can also do a search. I can search a file based on, maybe I know the first 3 letters that started the name of the file, but I can't remember the name of the file. So let's say this desktop directory now. I didn't know that I have this ability.txt file here. Or let's say readme.txt. I don't know that I have this file, but I know that I have a file that starts with read, but I don't really know the specific name, and I want to look for it. So I'll type this code, find, then I'll put this dot, which means I want to search in my current working directory. So this dot means I want to find in my current working directory. Then I'll put hyphen, then I'll type name. Then I will now search according to the pattern of what I want to look for. So first of all, I'll put this quotation mark, either it's single or double quotation mark. I will now say, okay, I'm looking for a file that starts with read, and put this star. So it means that it's saying that find a file in my current working directory that starts with this read, that starts with it. So any file or directory that starts with read is going to find it. So I will enclose it. I will enclose the read with a quotation mark too. Are you with me, sir?
Yep.
So this is going to find a file or directory that starts with read. So let's enter in my current working directory. So you can see it has found that file. It's saying that it's readme.txt. Can you see that, sir?
Yeah.
Okay. I can also do something like this. If I want to look at, I typed this code, find dot. So suppose I want to find another thing entirely. Instead of me to retype the code, I'll just press my up key, which is going to locate the last code I wrote.
The last command.
Yes. If I should press the up arrow key again, it's going to go to the next again. Look at this.
Okay.
This is the code I typed. And if I should press it again, it's going to go. I'm picking the commands. So I'm going to this one. So I can also try to find a file that ends with .txt. Look at this. You know that the star is now at the front instead of at the back. So this time means I'm looking for files that ends with .txt. So any file that actually ends with .txt, this guy is going to find it for me. So let's run it. So it gave me readme.txt, ability.txt. You understand that?
Okay. Which means the star behind means you start searching with the first word, and the star the front means start searching from the last, which is the TXT in this case.
Yes,
okay.
Exactly.
Hello, Emmanuel.
Hello, sir.
Is it necessary to put the points in front of TXT? If we search without the points, won't it still fine?
Okay,
No, I don't think it will.
Let's see it as it's not because it is a particular section.
No, not that.
No.
The point,
Full stop.
not the full stop before.
It's still going to search. So it's still going to search for it. It's still going to search for it. I can do that. This is what you are saying, right?
Put the star.
Okay,
yes,
the star.
Yes.
With the start. The star will be in front.
The star before the TXT.
Yes. It's still
Okay.
going to find it.
Okay.
It's going to find it.
Let me ask: is there when you write commands and there are spaces in between? Is there a difference? For instance, when you wrote the find command, you say find. There was space before dot.
Yes,
and there's a space again before the name.
Yes, there has to be space. It's just like
spaces.
Yes, it's just like you are writing a mail now. You space a space boy. That means you are a boy. But if you not leave space and you just combine like that, so it's like it's a single word. So your environment will be able to read meaning to what you just type. So there has to be space unless those two are together. So that's
okay.
Yes,
okay.
Yes. Okay. Without wasting much of our time, you can actually there are still more of these commands you can try. So I won't go through everything. You can go through them in your manual, your lab manual. So one more thing I want to talk about is the help command. So to use the help command is our own type help in this environment. I'll use the code man. You use this guy man. So you type man, then you are going to tell the environment what commands are you trying to get help for. Let's say you want to get help for the LL command as the developer has specified. You want to get help on this command LL. Then you type man, then you type the command. So this is going to give you the summary of how the LL command works. Okay, no manual entry for this guy. So let's check on the ls command. So you can see this output window. So this gave you the how the ls command works. It gives you everything. Can we see that?
Mm-hmm.
Yeah.
All right. So to quit, you said manual page first time. Press H for up or Q to quit. So to quit, I just click on Q on my keyboard. Then I go back to my terminal. Okay, the next thing I'll just go to is the VI editor. The VI editor. I have to run the VI editor command. So VI editor command, VI editor in your Windows environment. So to go to your VI editor from your Linux terminal environment, you type VI. So if you type VI, then if you open your notepad, automatically it just give you this kind of if you open it automatically, it gives you untitled as the title of the notepad. It will give you like untitled one. I think that's what it gives you. But in this case, I want to give it a name. Let's say I want to give it DASCA.txt. So what I want to open a DASCA.txt file. This file does not exist, but it's going to be saved as this name. So if I should press enter, so it's going to open an editor for me. So it has opened an editor for me, which is DASCA.txt. So this is like the name of the file. Do you understand? So you can type whatever you want to type there, as in your notepad, then save it. And so in this environment, you have the edit mode and like the insert mode and the exit mode. So in the insert mode, you can type whatever you want to type. But if you want to do any kind of edit, you want to edit the file, you have to exit the insert mode so that you can be able to do any edit on the file. Okay. So, yes.
When you finish doing your work, how do you save it?
So we are going to do that. So to enter the insert mode, you type I to enter the insert mode. I think I'm already in the insert mode like this. So you type I. So you click on I. So I'm in the insert mode already. So you can now type whatever you want to type. So I'll just type DASCA for professionals. So I want to go to the next line. Okay. I want to list the people in this class. Imilola, Ononeye. The second person. This is my name. See, I cannot edit. So let me just continue. I'll do that. So Sani. Then I want to type. I don't know whether Susan. I don't know whether I'm going to get this, but you can correct me, Sha.
That's it.
I think I want to write Dr. Abeng's name. Did I get it?
Don't worry, even if you write it in French, no problem.
I think I got this name too. So another person's name is Victor. Is Victor in this class? So I finished.
Yes,
typing.
I am.
Okay, I finished typing. Okay, thank you, Victor. I'll just escape. I will escape. So I'm no longer in the insert mode like this. I cannot insert. So suppose, okay, let me go back to the insert mode. Oh, there's something wrong. So suppose I want to type a name that is not part of this. Of this class? Let me say Sunday. And I realized that, I told you I cannot edit, I cannot delete anything in the insert mode, so I have to escape. So escape, and I noticed that, okay, I want to delete this last name I just inserted. The person is not part of this class. So to delete a character at a time, you use the X button. So let me just go start from here. Then I'll click on X. You see, it's deleting the character once at a time. Can you see that?
Okay.
Now, if I want to delete a single line, maybe I just, instead of me deleting one character at a time, I want to delete a single line at a time. I'll click on DD. I'll click on D twice. DD. So DD. So I'll do that now. You can see the line has been deleted. Now, if I want to delete two lines, at a time, I'll click on 2, then DD. 2DD means delete 2 lines. If it is 3 lines, that's 3DD. So let's try that.
But how would you know the lines you are deleting?
So the cursor, where your cursor is your current line. So DD is going to delete your current line.
Okay, for instance, we have number 1 to 6. If I want to delete 4 to 6, how do I do it?
Okay, 4 to 6. I'll just go to where 4 is.
Okay.
Then I'll do 3DD. So that's the 4 to 6.
Oh, okay.
So that's it. Now, if I want to quit.
No, don't go yet. In case that command was a mistake and I want to restore the 3 names, is it possible?
I don't think you can do that. I don't think you can do that.
We can.
I don't think you can do that one. But
That time.
Okay. Let me add my voice to that. So
Okay.
so it's not like Windows where you have undo. So in Windows you have undo where you can quickly automatically do undo. So this one is a little
Okay.
restricted. But however,
Okay.
is that you have already saved that file and you deleted some lines. You now notice that you're not supposed to delete that line. Just
Okay.
exit this place. Don't save this file. If you don't save this file, what you have always had will remain there.
Will be there. Okay. Okay. Okay.
But
Thanks.
anyways, if that can be done, I'll get back to you guys.
No problem. No problem. We are together.
Yes. So I'm in the exit mode like this. I'm in the exit. In the editing mode. So if I want to, I can save in this mode. You cannot save in the start mode. So in this kind of mode, that's when you can save. So how do you save? You just press the colon button. That's shift and colon. You can see the last line. You can see it's showing in the last line now. Can you see the last line?
Yeah. Okay.
Then W to write the file, that is save. Then Q to quit. So it's going to write the file and quit.
Okay. Write and quit.
Yes, exactly. So if you want to quit without saving, you just type Q, then exclamation mark. It's going to quit without saving.
Okay.
So if I should click on enter, so it has write the file and that's quit the VI editor. So if I want to see the file I just created, which is DASCA.txt, it's going to be in my current working directory. It should be in my current working directory.
Yes.
So the
Yes.
ls command should just give us that. So we just use the ll instead. So this is DASCA.txt that I just created. So I might want to see the contents. What's inside? cat DASCA.txt. Then these are the files. These are the contents in the file. We have deleted some, so these are what is left inside the file. So does that make sense?
Yeah.
Okay. So I will just hand over to Mr. Blessing to continue the class from here. Then we'll come back to this later. All right.
Ima, before you go.
Yes, sir.
In the help menu, is there maybe explanations on how this is used, can be navigated?
What is used?
That is the interface, the environment we are working with now.
Okay, you can't get the help for that one, but there are documentation that I can get online. Documentation for the Linux commands, you can get it online.
Okay.
Yes.
Okay.
No, I think his question is that what are the applications of this? Is that your question?
No.
What's your question?
My question is, are there documents we can read on our own or study on our own to know more than what you are giving us now on our own? How do we navigate this environment is what I'm asking for.
Okay, so the details of some of these things that Emmanuel has talked of, they are in the lab book. I'm sure you've been everything. So there is even more in the lab book with more detailed explanation than what he has already.
Okay.
Yeah.
Okay.
Okay, thank you. Thanks a lot, Emmanuel. So we are running a distributed lecture, So it's no longer like a classroom lecture, it's distributed. Okay, so thanks a lot. Thanks a lot, Emmanuel. Okay, so again, let's go back to the basics. So what exactly is this topic? So we are considering big data analytics, big data analytics, or DASCA big data analytics. And we have spent time to look at big data. In class week, we'll be talking about big data. So let's go to the other side of it, which is the analytics bit of it. But before we go into that, I'll just share one experience. One of the biggest projects that I did early in my career, about more than 10 years ago, when Soludo was the CBN governor. I'm sure Dr. Ben can relate to this. CBN said, CBN came up with this consolidation requirement. So all the banks will need to shore up their capital base to like 25 billion, 25 billion naira. So because of that, a lot of banks were merging. So at the close of that, when the window, there was also a deadline. So when that deadline was approaching, there were some banks that CBN just as a matter of intervention, like had to arrange their merger. Those banks include Bank of the North, Center Point Bank, Center Point Bank, ICD, TCB, Transcontinental Bank. There's also ICD, I can't remember what ICD stood for, but there was Bond Bank. All of those banks has to merge into what you currently know today. Oh, wow. A lot of people can relate to this. The entire team can relate with this because the entire works in
I know you're talking about me.
The entire works in Unity Bank.
ICB is Intercity Bank.
So I'm telling your story. So then, so we're supposed to do a project. We're supposed to help the bank to consolidate all of their databases together because these banks were running different banking applications. Some of them were running Oracle database applications. Some of them were running Microsoft SQL Server. Some of them were running Centerpoint Bank. Then was running an Excel, was running Excel application. That was the first time I was going to see a banking application written in Excel, very robust application. One other bank was running on Linux environment, this thing that Emmanuel just showed us. So because the Linux environment is a lot more secure than Windows environment, hackers can hack a lot of things, but a lot of them cannot really hack into a Linux environment like that. Except maybe there's an insider that is giving them some of those information. So yeah, but in that project, what we did, that was a very big data project because like Bank of the North had about 200 branches alone. We had to consolidate data from those 200 branches, not to talk about TCB, ICB, CPB, Center Point Bank, and the rest. Now, one interesting thing about them is that they all had different kinds of applications that were moving the data from those different applications into one single application. That's a data project. It's a very big data project. And essentially part of it also was also identify some of those inconsistencies that can affect the bottom line of the business. So generally, there are so many applications of big data, like after what's it called, Access Bank and Diamond Bank also merged together. I'm sure they're also going to be having some data issues, which may not be very evident. It's about 1 year now that they have merged together. About almost 1 year they've merged now. But over time, there is now going to be some inconsistency because of disparity in their processes. If you look closely, there is going to be some big data applications for some of those challenges that they have. So think beyond whatever we are teaching you in this class. Try to look for more applications beyond some of those things that are taught in the class. So having said that, so we are switching to So we've done the big data side. Let's switch to analytics side. The training or this particular subject is mainly about, or this course is mainly about analytics. So let's go into analytics. What exactly is that analytics? What does it entail? What are the components of analytics? What are the tools for analytics? You know, and at the end again, at some point again, I'll hand over back to Emmanuel so that he can take us through, introduce us into one of the tools for conducting analytics in the big data space. Please feel free to stop me at any point in time to ask any question. The way you were stopping, I was jealous of Emmanuel because you were stopping him and you were asking him questions. Okay, so in this part, we are going to be looking at and reporting. A lot of people do reporting, you know, but there is a difference between analytics and reporting. Then we also look at the basic features we are looking at the features of basic analytics and what is called advanced analytics and some of the skills that are required for analytics. So by the way of introduction, I know I mentioned a little bit of this last week. Analytics is the process or is the act of combining data in a very intelligent way, or is the act of applying statistical, mathematical, and computational concepts in looking in identifying patterns and relationships between data sets. You know, so there could be some patterns in data sets that except you apply some tools to see those patterns, you will never ever know that those patterns exist within the data. Or having that knowledge of those patterns can give you significant leverage in the market space. I worked on a project in a company. That company was losing about 9 billion naira every year, and they never knew, and they've been losing that 9 billion naira for like at least 3 years. They never knew until we engaged their data. And what we're just looking in data was some kind of relationship within the data set. That was when we discovered that for the past 3 years, we've been using an average of 9 billion naira in a year, you know, and then we plug that for the company. So analysis is just that basics of looking for patterns and relationships between data sets. When you compare it, by the way of comparison, when you compare it with reporting only like provides data. Okay, can you give me data for everybody, all the sales that we made last year? You know, reporting just provides data. But when it comes to analytics, or when we do analysis, we are not just providing data. We are trying to answer some specific questions. You know, we are trying, why are we losing customers? You know, so this is why we are losing customers. It's not just providing data about customers that we have lost. No, we are not just providing data about customers that we have lost. But why are we losing those customers? Reporting tries to just focus on questions that is asked for. People who do reporting, they really don't think outside the box. I was engaging a colleague of mine. The guy said, see, most times those who do analytics, you cannot really box them up. You cannot box them up and say, okay, you must do things only in this particular way. And no, you can be creative, and that is why in my definition of analytics, I said it's an art. It is more of an art. Though there are scientific tools that we use to generate that art, but it is more of an art than a science. Reporting is usually standardized. You know, your reporting is usually standardized, while analytics is customized. Then also in my company, people have said, Blessing, for this analytics that we do, why can't we develop a product for it? By the time we develop a product for it, that means we are reducing analytics into reporting. You know, we are reducing analytics into reporting. If it's just reporting that we want to do, we can easily develop a product. But when it comes to analytics, you may not really have a product like that for it. You might need to always customize the product that you get out of that you use to generate analysis. You might need to always customize it. So now, whenever you want to undertake analytics process, there are some basic steps that you need to follow. If you are first timer into it, a lot of people ask me, "Blessing, I want to be an expert in this space. What are the steps I need to take?" These are those steps that you need to take, when you want to undertake analytics. The first step ever that you need to take is to understand the problem that needs to be solved. And this is that area. If you remember last week, we talked about there are tools. So the fundamentals, the basic elements of big data. Number one, you have you have the data itself. There must be data. That is why it's called data science. That is why it's called data analytics. There must be data. Then there are tools and technology that you apply on that data. Then finally is the understanding, the know-how, the domain expertise. You need to understand the problem you want to solve. So if you want to build an economic model, for instance, or you want to apply analytics on some economic problem, you need to first of all, the beginning point is to understand the problem that needs to be solved. If you don't understand the problem, you probably don't know the data that you need to solve that problem. So the basics, 101, you need to understand the problem. So and understanding the business problem that needs to be solved would require what is the business objective? What exactly do we want to achieve? Do we want to cut costs, or do we want to generate more revenue? Or do we want to acquire more customers? Or do we want to reduce inflation? Or do we want to grow our margin? Or do we want to reduce fraud? There must be a particular objective that we want to achieve. Then the next step is to assess the situation. So how bad is it? If it's a fraud case, how much do we lose on the average? We need to have that understanding. Is there a particular location that this is prevalent with? Assess the situation. Then now determine what data do I need in order to be able to solve this problem. The problem you want me to solve is to reduce the rate of fraud. So what data do I need in order to solve that problem? Then you produce the plan. That is step number one. That is step number one. Then step number two is now is what they call data exploration. No. It's called data understanding. That is okay. So now I need to know what data do I need. We in Object Analytics call this like we call it pre-analytics. Pre-analytics. So before you do analytics, there are some processes that will precede that analytics. Understanding data. So you need to collect the data that you need for that exercise. You need to describe it. You need to describe it sufficiently. So if you bring me to a new space, say you take me to what sector now? Say you take me to the military, for instance, and you want me to predict say, okay, maybe we've been collecting data on all the bomb blast incidents, So you now want me to build a model that will predict when likely the next bomb blast is going to happen and where is it likely going to happen, I've not been in that space, and it's a new space for me. So the first thing I need to start with, after understanding the problem or the issue you want me to solve, next thing, give me the data that you have, then you describe that data, you explore it thoroughly, then you verify the correctness of the data. At times, there are some data that don't make sense. You can say occupation, then so you see some people's occupation. So occupation can be housewife. But when you go and check the gender of somebody who says that his occupation is housewife, the gender of that person is male. So when you look at it, if it's not in a gay or lesbian kind of environment, African kind of environment, that data does not make sense. How can somebody's occupation be housewife and the person's gender is male? So you need to understand the data for consistency, for correctness, and stuff like that. Then the next thing is to now prepare the data. You can have so much data, but you need to select the one that you need for that exercise. Then you clean it, and then you construct, and then you build your model. After building your model, you evaluate the outcome of that model. We are going to be going through all of these different phases at different points in this class. So maybe we've spent the last week to talk about the different applications, different business problems. Maybe the following weeks we'll be talking about how to collect data, how to describe data, how to explore data. Then we'll now go to how to select data, how to construct data, how to integrate different data formats. Then we'll get to the point where we'll be building models, and then how to evaluate the models. Then we'll also get to the point of deployment. So we'll go through all of these stages throughout the lifetime of this particular course. So understand the problem, or understand the business requirements, understand the data that is required, prepare the data, then build your model. After building your model, you evaluate the outcome of the model. After evaluation, then you do the deployment. Those are the different stages of analytics. So analytics there are basic analytics, there are very basic kind of analytics, and there are what they call advanced analytics. Basic analytics, more or less, will be looking at what happens, when it happens, and what is the impact. So basic analytics, most times they are descriptive in nature. Basic analytics, they are looking at the past, what has already happened, But advanced analytics is looking at it maybe in futuristic perspective. Okay, so based on this trend, what will likely happen? It has not happened yet, but what will likely happen? Or this advanced analytics tries to recommend, a better way of probably getting of optimizing a particular process. But basic looks at the past and historical and descriptive. Advanced is predictive and prescriptive in nature, and it's also diagnostic in nature. Try to, okay, what is the root cause for this thing? So it goes deeper beyond just the surface of what happened and when it happened, So yeah, and the application, there are uncountable applications of advanced analytics, basic analytics. There are many applications of it across different industries. In pricing, if you have a company where you have to determine the price for a product, like the telecom companies, for instance, pricing, it's a big deal. You cannot just sit down and determine your price because competitors have the same product out there, and you are looking at your cost, you are looking at competition. So how do you determine the optimal pricing? In basic economics too, in determining that point of equilibrium. So there's a lot of model that goes into it. But if you now want to determine that in a futuristic manner, then you probably would need some advanced analytics. In economic analysis, you want to fix the price of, maybe you fix exchange rate, for instance, or you want to fix the price of maybe you want to fix interest rate. There are a lot of data sets you need to collect and combine them in some logical way so that you'll be able to determine it in a way that helps you to achieve your economic objective within a particular time period. Then there's another thing that we do that we call segmentation. A company I worked for spent about maybe $1 million or $5 million, I can't remember, to do customer segmentation. It's a big deal. Even LBS too. They invited me for an event where they wanted to do they've done a segmentation, this market segmentation of the demand side of financial services, essentially looking at the different demographics, how people behave, based on that, it will help them to determine what type of products to create. So those are some of the different applications of data analytics across different sectors. Also has application. Now, one question is, what are the different? So generally, all of these analytics exercise, They can be, they have a broad, classification, or they have a broad classification. So some of them are, they have a broad classification. So if you are undertaking data analytics or data mining, for instance, if you are undertaking data analytics, it's either you are doing it's either the problem you are trying to solve is either it's like a classification problem. I think somebody asked for a cheat sheet. I have that cheat sheet. Let me quickly look for it and share. Cheat sheet. Yes, machine learning cheat sheet, data science cheat sheet. Yes. Okay, so I'm going to share this immediately after this class. I'm going to share this immediately after this class. Okay, so generally, when you want to undertake analytics problem, there are some broad categories of problem you can solve. So it could be like a classification problem. So I give you a population, I give you a sample of data, and I say, please just classify these guys into different groups. So it could be so maybe, for instance, maybe you work in a bank, for instance, and you work in a bank, and the question is, okay, and you have like 10 million customers in that bank, and you ask that out of these 10 million customers, can you tell me which of these customers will go to the banking hall next week? Can you tell which of these banking customers, out of 10 million customers here, which of them will go to the banking hall next week? So we want to classify customers, those 10 million customers, into this group, two groups. Go to bank next week and not go to bank next week. That's like a classification problem. It could be, okay, can you classify if my customers are going to churn or they're not going to churn, if they are going to buy or not going to buy? It could be more than two different classes, but put them into different groups. Then you have what is called logistics regression, which is also a form of a classification. It's also a form of a classification problem. You have neural network. That one is very advanced. So you have neural network. What is that? So it runs multiple iterations in order to be able to determine the answer to a particular problem. So like it goes through several loops. Like a network, goes through several loops to be able to determine the solution to a particular problem. And then you have clustering. Clustering is where in this case, when they do clustering, it's also classification, but in this case, it's not supervised classification. So when I say it's not supervised classification, it means that take this data set, just group them based on what they have in common. I'm not telling you what features you should use to group them. For instance, in the classification example that I gave earlier on, I said that take my 10 million customers and group them into whether they will go to the banking hall or not go to the banking hall. But in clustering, you are not telling them how you should group them. You are just saying group these customers. Cluster them. It's used a lot in segmentation. Just cluster them. I don't know how you want to cluster them. I don't know what you are going to use to determine that cluster, but just put them into different groups for me. Then you also have anomaly detection, which is also applicable in fraud detection. So in an anomaly detection, can you tell us, out of all of these transactions that is generated in our bank, which of them is abnormal? It does not follow the normal process. And I gave you a classical example of this. You go to ATM, you have an ATM card, you go to ATM, and you have never ever withdrawn your transaction limit. You have never withdrawn your transaction limit. Then, and maybe the latest time you ever use your ATM was maybe 4 p.m. in a day, 4 p.m. or maybe 7 p.m. in a day. Then suddenly, that ATM is being used around 11:30 p.m. in the night, and the person is withdrawing the limit for the day. And the following morning again, the ATM by 12 a.m., like few hours after, by 12 a.m., the ATM is being used again and the person is withdrawing like almost something that is more than what the person normally will withdraw. The ATM should have that intelligence to know that this is an abnormal kind of transaction. So you can maybe swallow the card or ask for a second level authentication that, okay, how am I sure that the owner of this ATM that is generating this transaction? I hope that the owner of this ATM is not at gunpoint. Then you can put some logic on it to protect your customer. It's something that our banks don't do. It's also something that even in the whole world, no bank is doing that. So it's a solution that can be put out there in the market that and if it's properly demonstrated, I can assure you that it's going to bring a lot of value for anybody that loves that kind of solution. But that is anomaly detection. Okay, so yeah, so that is intro into big data analytics. So there's a question here, and I'm going to throw this question to Susan. Her microphone is working today. So Susan, please, can you discuss how advanced analytics can help a sales manager in a particular corporation? So there's a guy, he's a sales manager in, say, let's say he's sales manager in Abuja Electricity Distribution Company, and the guy wants to analyze ways to increase his, he wants to increase his sales. He's a sales manager, or he's a territory manager for Abuja Electricity Distribution Company, and he wants to increase his sales. And he's not planning to use estimated bill. He's not using estimated bill. He wants to generate more money in a valid way. So can you discuss how he can go about it, applying the concept of analytics? So your microphone is muted.
Huh?
Yes, now we can hear you.
So you said he wants to use an estimated billing or what? Hello? Is that blessing?
So let me go back to the question.
Yes, please.
So this is the question. So discuss how advanced analytics can help a territory manager of Abuja Electricity Distribution Company. So there's a guy, he's the territory manager of Abuja Electricity Distribution Company. So how can he apply advanced analytics to increase his sales and profits without using estimated deal? He's not using estimated dealing now, but he wants to apply advanced analytics to improve his sales. So how does he go about it?
I want to do that.
I'm just laughing with the way you are having a deep breath.
I'm trying to. I don't do estimated bills. You understand? So I'm trying to see how I can explain this.
Okay. So
this is a tough one.
Okay, so that's it. I'm going to come back to that question. I'm going to allow you some time to think it through, But I'll come back to that to that later on. But so I want you to think about it. How can you apply analytics? So you have been promoted as a director of sales for Abuja Electricity Distribution Company, and you want to apply analytics to improve your sales. How do you go about it? So those are some of the things that you should typically think about. We talk about, so I'll come back to you later on that.
No problem.
So we've talked about the different characteristics of big data. We talk about volume, variety. We talk about some of the skills that are required for a big data analytics. So some of the skills required for big data analytics. Some of them are the stuff that we are going to be learning we are going to be learning in this class. Some of those skills, some of the tools, how to use some particular tools. There are so many tools that are out there in the market. So how do you get proficiency in the use of a particular tool? Let me see, skills. So we're talking about some specific tools. There are so many tools that are out there in the market. Even as we are speaking now, some people are somewhere developing a particular tool. The next thing you've heard about, there's another tool again in the market. But whatever the tool is, if you understand the first principle, and that is why a lot of people in this class, that is one of those things that they have engaged me on. That blessing. I don't just want to pass this DASCA exam. I want to know this thing, and I want to know it very well. So maybe what we are using in the class is R, for instance. If by the time my organization is going to deploy this, my organization decides to deploy maybe SAS or Oracle, for instance, the knowledge I have acquired in this class should be able to take me through how to leverage those tools that have been deployed in my company. So, as I said earlier on, you need domain expertise, and almost everybody in this class, they're already domain experts in their own area. Then the next thing I need to add to that is the tool and the technical know-how to be able to leverage the data that is available to you. Some of those things you need to know. You need to have some knowledge of statistics. You need to have some basic statistical skill. You need to know some basic computing concepts. Some basic computing concepts. You need to know a lot of mathematics, and then maybe some basic programming too can also help. As much as this, all of that, they are also covered within the curriculum for this class. Please feel free to ask me any question. Feel free to stop me at any point in time.
Hello, Blessing.
Okay, hi.
Sorry, I got distracted when you were trying to answer that question that you asked Susan. What was the right approach to the answer?
No, I did not answer her question. I said I was going to come back to her. I did not answer her question. I left it, so we'll go back to her. I have not answered the question yet. So let me scroll back a little bit. So this is the question again. How do you discuss how to apply advanced? You are the sales manager of Abuja Electricity Distribution Company. So discuss how you can apply advanced analytics to help in driving sales for your organization. I've not answered the question yet. I'm still leaving it open. We'll come back. We'll definitely come back to that. So I now move to talking about some of those things that we have reviewed before, talking about them and the skills that are required as a data analyst. I have some. So we hired some. We have a graduate training program that is going on. That is for fresh people that just left the university, maybe maximum of 1 year of experience. Those are people that are in that program. I try to encourage these people that, see, you need to know as much as possible, know a lot of every aspect of it. There is the data engineering aspect, there's the data analysis aspect, there is visualization aspect. There are many components that make up data analytics in general. It is good you know everything 360, not just one aspect of it. In my company, I have some people, when you give them a project, they will say that, oh, I'm waiting for data, I'm waiting for Edward to give me data. I will let them know that, see, that data you're waiting for Edward to give you, it will only take Edward 30 minutes to get it done. So why not also learn how to get that data by yourself? So that it's not like maybe it's in 3 days' time when Edward now has time for you. That is when you will now start doing your work, what you could have also done all by yourself. So there is the data. There is the data engineering part, which will require some kind of programming. There is the data analysis part, which will require some knowledge of statistics, So those are some of the skills that as a data scientist or as a data analyst you need to have. Then also there's also a tussle between the IT guys and the analytics guys in terms of who owns analytics. The IT guys most of the time want to take ownership of analytics. They want to say that, they own analytics. Why the analytics people will say, no, we are not IT people, we are business people, we understand the business problem. So that is also a conversation that you're going to be having within your organizations in terms of who exactly owns analytics. It's always that context. The IT people are always involved in that context because they own the equipment, they own the infrastructure, and maybe the infrastructure comes from their budget. So because of that, they think that they own it. But me personally feel that it is not IT that owns analytics. It is the business that owns and that will drive analytics. IT can only be a support department or a support function for analytics. But in terms of managing and driving the analytics requirement for a company, it is purely the function of the business. It's not the function of the IT guys. Okay, so there's another question here again, which is discuss the role of IT and analytics team in big data projects. So before we answer this question, I'll go back to Susan. Susan, do you have an answer to the question we raised before? Do you have an answer now?
No, I don't have right now. Sorry, Mr. Blessing.
Don't call me Mr. Blessing. You want to use Ojoro for me. So it's actually a very simple problem, and then it is me to have the answer. I want to get it out of you. Go on. Give it a try. Just say something. Okay, so I'm waiting.
So to increase sales, right?
Yes.
Okay, let me just break it down like this. I don't know anything about estimator billing, but the thing is, aside from estimator billing, there's this thing, the other one, prepaid. Do you get?
Yes.
So for the prepaid, that's the prepaid. Yes, people, you buy your token, you load it, blah blah blah, and all that. What the way I feel they can increase sales is this, and which I think they've been doing. It's by when you take, let's say two business units, and say, okay, fine. Oh, these people, this is where I have my high value customers, right?
Yeah.
This is where I have my high value customers, and they pay more and all that. So what I'll do is, in 24 hours, I can give them 23 hours of supply because I know I will get revenue from them. Do you understand?
Yes.
I'll pump more energy there compared to other places. I know that these people, they don't really pay much. So why do I have to waste my energy, my consumption on these people? I don't know if what I'm saying makes sense. Hello?
I can hear you. I can hear you.
I don't know if what I'm saying makes sense.
It makes a whole lot of sense. So it makes a lot of sense. So let me recap what you have said. What you have said is that, so first of all, you need to determine where you have the high value customers. So you understand? And then you pump more energy to those locations where you have people that would optimize the energy supply more than anybody else.
Yes.
So you have brought in a concept that is called high value customers. High value customers. I'll look for the early high value detection model. Okay, so okay, so I want to quickly share my screen. I don't know. So can you see? So you brought in a concept, and I think. So can you see my screen? Can you see early high value detection model on my screen?
No.
Not yet.
Okay, so I'm going to disconnect and share. So so let's talk about early high value detection model. So yeah. Okay, so this is my screen. So you brought in this. So you brought in the concept of high value, high value. So in telco business and in banking business, it is 100% applicable too. Knowing who are high value customers. You know, if you do your pyramid of revenue, there's pyramid of revenue and pyramid of customer. You know, there are, so if you have that pyramid and you have inverted pyramid, you notice that in the normal pyramid, there are some few customers at the top. There are some few customers at the top that generate a lot of revenue. So something like so I just show you what that looks like. So say this is a pyramid, say this is a pyramid, and this is another pyramid, like this. So this some of those things that we have seen in the past. So it's a pyramid. So you can have a situation where you have some customers at the. Please mute your microphone. Oh yeah, put your microphone on mute. Okay, so you have a situation where you have some customers, very few customers at the tip of this pyramid, and these customers they generate most of the revenue for your business. So why can't I give more power to these people at this part of this pyramid? Why don't I give custom power to people within this part of this pyramid that can help me to generate this revenue, rather than giving power to people at the bottom of this pyramid, something like this, and all they generate is maybe some revenue that is like this, you know. So this is a concept, but the question is that how do you, so as the director of sales or as a territory manager within your territory, how can you identify the cluster of those customers, the most cluster of customers that are in this particular section of the pyramid? So you need a lot of data to be able to determine those customers where you have most cluster in this location. You know, unlike in maybe in banking business, you can easily analyze that data and maybe, well, it's similar. I think it's similar because in this case, the people that are in this part of the pyramid, they may not be living exactly in the same location. Well, in some cases, but in many cases, the affluent people, they live together within the same cluster. So it will be even easier for you to determine this cluster, and then you channel your distribution to this cluster so that you can derive this revenue, rather than giving more distribution to people at this red cluster, and then this is the kind of revenue that you make. Thank you very much. Fantastic example, which is also valid in telecom business and in banking business. That's what we call early high value detection model. Those days, you know, when I was in my former life, you know, one thing that we do is that at the time of acquiring new customers, at that point you want to determine as quickly as possible whether that customer is a high value customer. If we know at the point of onboarding a customer that is a high value customer, the way we engage that customer will be different from how we engage customer in general. So you can look at a company like, say, Etisalat. Etisalat says recharge of 100 naira. They also say recharge of 10,000 naira. So if they are acquiring a high value customer, they will not want to be campaigning, they will not want to be sending SMS of recharge 100 naira and get 500 naira. You don't want to be sending that kind of a recharge, campaign to the high value customer they've detected. So we built a model that we call early high value detection model. So every new customer that is acquired is passed through that model. Every new customer that is acquired is passed through that model, and from that model we identify, okay, who among these new customers has the attribute of a high value customer. Mind you, that customer has not even generated so much transaction yet. It's just that the basic information that the customer has provided at the time of registering that customer. That is what we are using to determine that it's a high value customer. So we now have a cluster of people that are high value. So from that cluster of those people that are high value, we now have an engagement plan for them. And that engagement plan will be directly tailored to the kind of what we have identified from their value, So that is just like an application. That's an application of big data. There are so many other examples that we can possibly consider. So let's go to let's look at some of the tools for that is applicable in big data before I hand over again back to Emmanuel. Let's look at some of the tools that are applied in analytics. Some of the tools. There are so many tools. Again, as I said, those tools they are always being worked on. So there are some people that are doing research and development on a particular tool to solve a particular problem. Once they discover another kind of a problem, they go and develop that tool. When people go and do PhD or when they go and do masters, and you see that those masters, they are fully funded in countries like Canada and the US, you will now be asking questions that, okay, the people who are funding these masters, the question is that how exactly are they, what is the need for them? If you are paying about maybe $50,000 for a number of students that are doing PhD or they are doing masters, what would be a need for them? So what is the need for them is that most of these institutions, they have professors that they partner with in these universities. So they may want to research on a particular subject. So they give the grant to the professor so that the professor will recruit students that will help it to research on a particular topic or in a particular area. So the finding of those students is now taken back into their lab, into creating product. They now create a product and then they sell the product to us in Africa and to the rest of the world. So that is how their whole economy actually works. So when they give that grant to those people, they actually want people to research. So if you want to predict or you want to do segmentation or you want to do some economic analysis, so they can give it to professors in the university, okay, do this research for me. So we just take this money and work on this project for me. The output of that, the professor return it back to the organization, and then they use that to develop a tool, and that tool, they sell it, they make more money, and they find more problems again and take it back to the classroom. So that is actually how the economy works. So those tools, there are so many of them. However, there is what they call the first principle. So one of those things we are going to be learning in this class is actually the first principle or the principles of data analytics. Okay, so in terms of evolution of analytics tools, they are used for data analysis. They are used to execute some kind of analytical algorithm. So if you want to run some type of algorithm, for those that are conversant with if-else statement or if-else scenario, if you are working with maybe a number of variables, say 5 variables, 10 variables, you can easily do if-else scenario. But by the time your variable is running into 100 or 1,000 and you want to do if-else scenario, you'll be lost. Even if you can do it, maybe the application, if you are trying to use Excel to do that, the application can even crash, because it cannot load that kind of a data, or it will be too slow because the data that you're working on is very large. So based on that, they now develop another kind of algorithm that they call machine learning algorithm, and they develop them in a way that they can be automated. So you don't have to like start touching things one by one. It's not manual. It can be automated. Then so with those analytics, it will also help you as a professional to focus more on the result than focusing too much on the problem or focusing too much on solving the problem. You focus more on the result and the interpretation of the result. These have evolved over the years. In the 80s, they have what they call job control language, which is like a batch processing job. In the late 90s, they started developing a graphical user interface, maybe Visual Basic. Microsoft developed Visual Basic, so it was no longer as it used to be. It was more interactive interfaces that they were developing. In 2000 and late 2000, they now developed what they call they've now created automations around some of those tools that they are developed. So it's more or less like now drag and drop. So you don't even need to know how to do a lot of programming for you to be able to do some predictive modeling. There's a tool that I'm going to show you later on in this course. If you want to do predictive modeling, just take your data, feed it into that tool, click one or two buttons, submit it. Once you submit the job, it does your prediction for you and it gives you your result out there. But that one will make you lazy, So we'll take you through the first principles, the fundamental concept. Then later on, we can now show you how those tools make things a lot easier. It's like learning how to drive with a manual car, but eventually you've been driving automatic car, but you actually learned how to drive with a manual car. Yeah. So so those analytics too, generally they can be divided into two groups. You have the statistical data analysis tool, and then you have the visualization. You have the visualization tool. The statistical tools are for analysis. The visualization tools are for presentation. And it's very important. That presentation it's very, very important. It's how you tell the story from what you can find in the data. So we are not going to bother about these questions. So let's start with R programming language. And after this part, I'll hand over back again to Emmanuel to show us through the R environment and how to we'll now start running some R commands, just as we did earlier on. So R was developed by some two guys. Their name starts with R. That's why they gave the programming language. That's why they gave it R. There's Robert Gentleman and Ross a hacker. Because both of their names start with R, Robert and Ross, they decided to give the programming language R, but originally it was S. R is open source. Open source means that you don't have to pay to access the code of R. Open source means that you can develop another component of R and make it publicly available, and then other people too can reuse it. So it's open source, and it's used by a large number of professionals across the whole world. I have a friend who just came back from the US. She was doing analytics for some NGOs in New York. All they use is R and maybe one visualization to present the results out there. And one fantastic thing about R is that R has integration to programming languages like Oracle. It has integration to Power BI. It has integration to Tableau. It has integration to to Excel, you can integrate R with Excel. So if there's a function that Excel cannot handle, R has integration with Excel in such a way that you do your analysis in R and Excel presents the result for present the result for you. R is what they call object-oriented. So if a programming language is not object-oriented, it means it is procedural. Well, what it means is that if it's procedural, it means that if you want to write 1,000 lines of code, for instance, you start from the beginning and you will end at the end at the rock bottom. So just one line. You cannot split your program into smaller components. You can't split it into smaller components. But with R, if you have a lot of things to write, for instance, maybe you want to analyze market share, you want to analyze inflation, you want to analyze the number of customers, you want to analyze maybe like 10 different things. You can write different components and combine them together. You can write them as different components and combine them together as a single program, or you can even run them independently as separate programs. But when it is not object-oriented, you cannot do it that way. It's only one program. If you want to do 10 analysis, it is only one program that you write for all of those 10 analysis, and you can only execute all of them together as one. But in R, it's not so. R is object-oriented. You know, it can be linked with other programming languages, which makes it very powerful. You know, it can be linked with Excel, it can be linked with Power BI, and most commercially available tools, Power BI, you know, they can be integrated to R, and also so R is also available both in academic environment and research environment. However, it has some limitations. You know, it has some limitations. So R runs in memory. You know, so what that means is that, how do I explain that? So R is resource intensive. It runs in memory. So if your computer does not have a large RAM, when R is running, no other things will not be able to run properly. You know, or R may not run properly if you don't have enough memory to accommodate the process. So R runs in memory. While some other programs, they run from the file system. Anything they want to do, they go and copy from the file, they run it, return back to the file. But R runs directly in the memory of the computer itself. So that's why we talk about you having large memory for your PC. You know, so even when the data set is very large, you know, or the maximum size of file that R can handle is the maximum size of the memory that your computer has. If the data you want to run has more is bigger than the memory of your computer, the R program will not run properly. You know, so it will not run properly. Then so in some cases, so R may not be. So it's the concept of distributed computing that now make R usable. You know, in big data, there are other ways. So it was a workaround. It's those distributed computing concept and parallel computing concept. That's a workaround for R programming itself. And R is fairly intensive. So it's okay, I've talked about this. It's fairly intensive process. That means it's resource intensive. It consumes a lot of memory. It consumes a lot of CPU time when it's executing. You know.
Hello, Blessing.
Hello, sir.
Sorry, let me just break you briefly. In our discussions last week, we made reference to most of these institutions having their data warehoused in the IT department, you are only given a link to the data, which does not depend in this case on the size of your system. Does this also apply to the limitations of R?
Okay, so okay, I also want to make reference to the discussion I had around the context between the people who own analytics and the IT guys. You know, this always bring up that conversation because the IT guys always want to manage. They want to manage the resources that they have. So most of the time, even in terms of memory space, if they give you memory, they want to limit it. If they give you more memory, they'll be complaining. So again, when it comes to the implementation itself, we will rely on the IT guys to provide us with the kind of infrastructure that we need. You know, we need a lot of memory. IT needs to provide that a lot of memory because if the data is large to some extent, if the data is very large to some extent, and the memory is not able to accommodate it, then it's going to be an issue for the program. It's probably maybe the program is just going to be crashing. So most of the time, the analytics practitioner would need to recommend to the IT guys exactly the resources that they need. And whenever I do that kind of recommendation, I'm not frugal at all. Even I normally ask for more than what I need. I told you that we set up a server, and the memory of that server is 128 gigabytes. You know, the 128 gigabyte. There are servers that have a lot more than that, but 128 gigabyte of memory, it's like very, very large. So when I now have a data project I want to do, so what I'll now do is that I'll break the job into smaller tasks. I'll break it into smaller tasks so that at least it will not be up to 128 gigabits that I have available in the memory. If there is any data that I've seen that is bigger than one single file data that is bigger than 128 memory, it's a data I saw from Slumberger. So we did a training for some guys from Shell, and they brought their data. They got that data from Slumberger, which is an oil exploration company. One single file was the size of one file of that data was around 363 gigabytes. So we didn't even have where to load it. So we could not analyze the data because the size was larger than how much memory that we have available. So there should always be that conversation with IT in terms of how much memory you need for your big data analysis. I don't know if that answers your question, sir.
It does, but my concern is that many times what is in the server for some organizations can never be contained in a system. The servers are always larger because they carry more information. My concern is if we have to access that database and yet R has this limitation of memory, is it still possible for us to access that database using R to do analysis? Since we know very well that there's no way a PC can carry that. Even if a PC has 2 terabytes, it can't carry what some organizations have.
So, but the point is that you are not also going to load all of the data into the memory at once. So it's not like you are not analyzing all of that data all at once. So at the end of the day, maybe for your analysis that you want to do at a particular point in time, the maximum size of the data that you would need may be sizable enough to be contained in the space that is available, you know, because it's not all of the data that you are loading all at once into the memory for you to do your analysis. So even though there's limited resources, that limited resources may be sufficient enough for most of the analysis that you need to do.
Let's progress.
Okay, that is number one. Then also, again, another way that also at times the data does not also like, so the IT guys also have the way of dimensioning and planning. So the data also does not just suddenly just grow overnight like that. So when the need to also expand the resources when it comes, they expand it, you know. So there is a plan, there is some kind of IT approach to optimizing the resource that they normally have available. Yeah. Okay, so yes, okay, there's also SPSS. So there's also SPSS by IBM. There's SPSS by IBM, which is a statistical tool. It's been long ago. You know, SPSS is statistical package for or I think special package for statistical software or something like that. It has package and software and statistics in it. So those are so that's another tool, and then there are a few other tools. Let's just mention a few of them before we go into. There's also SAS. Yes, there's SAS. SAS is statistical analysis system. It's been around since 1976, mainly on IBM mainframe. You know, I told you I did a project with MTN that we had to do SAS. Before then, we've never done SAS before, but we just knew that we understood the basic principle. And by the time we eventually connected our data to SAS, we're already building predictive model with it. So those how to do that, we should be able to learn some of them from this class. Yeah. So you have SAS then. So there is a comparison among the three of them, as SAS, IBM, and R. R is open source. IBM is not. SPSS is not open source. SAS is not open source. All of them have GUI. They have editors and GUI that you use to interact with them, but other ones are more visually appealing because, of course, there are companies that are investing in those different in these two, SAS and SPSS, while R is more or less open source. So so because it's open source, there's not so much investment into how visually attractive it looks, but it's also good enough for you to do your analysis. R may not be as user friendly as IBM, SPSS, and SAS. And why it's not user friendly is because, of course, it costs a lot of investment to make an application user friendly, but it's also sufficient enough for you to develop your project. In terms of data management, so SAS and SPSS, there's a lot of investment into them. You know, that's why they look better, they seem to perform better, you know. But the fact is that if you can do R, you know, it's like learning how to ride with a manual car. If you can do R, by the time you move to SPSS, it's going to be like an easy ride for you. R has a lot of documentation, you know. It has a whole lot of documentation. SPSS does not even have any documentation. It has limited documentation. So when you're working with SPSS, you just need somebody to guide you on how to do some stuff because it does not have documentation. But R, you can sit down with R all by yourself, and then you find a way. Okay, you find documentation right in that R environment on how you can navigate through the system. SAS also has a whole lot of documentations for it. So let's close this. Let's go into R itself. Let's look at R in much more detail. So Emmanuel, are you ready for us? I want you to take us into the R environment and then walk us through how to load R and how to do basic stuff in R. Emmanuel, are you there?
I'm here, sir.
Okay, so I'm switching. I'm handing over to you. So can you take us through the R environment, in the virtual lab environment, how to start the R studio and how to navigate through the R environment?
Okay. Dr. Abeng, do you have your virtual lab environment? Hello, Dr. Abeng.
Hello, Imam. Hello. Hello. Hello.
Hello, sir.
Hello, I'm hearing
Dr.
you.
Abeng.
Yes,
I
sir.
say your VMware still alive.
What am I?
Your VMware workstation, is it on now? Is it on?
Let me put it on now.
Okay. Like this, your VMware workstation still on. Hello, Susan, can you hear me?
I can hear
Okay.
I can hear you. Hello.
Okay, I can hear you.
Do you want us to? Yes, it is
Yeah.
on.
Just use this and look at the game. So to launch the you just use this
I can't see your
icon
screen
there.
though. I can't see your screen. Okay.
I'll share my screen. Hello, Susan, can you see my screen?
No, I can't.
Dr. Abin, can you see my screen?
Yes.
But I don't know why Susan.
I'm having challenges here.
What's wrong with your VMware?
Screen no.
Okay, Temnola, you can't see my screen.
Yes, I can't see your screen.
What happened to your VMware?
I can't see your screen.
I'm asking about your VMware.
Oh.
How about now? You can see my screen now.
Yes.
I can't.
Yes, I can see your screen.
I cannot.
So who is the network? How about now?
No. You can't see it.
Submit. Spend out again. Can you see the virtual lab environment?
No.
No.
Oh, no, can you see it now?
No.
No.
Not yet.
I have to share my name. Hello guys, can you see my screen now?
No.
Okay, I have to. Let me switch back to another PC so that we can do this. Just go. Maybe it's this. I'm just going to. So I will share my screen again now. I'll go that you can see this. Can you see this screen?
Yes,
The
I
screen
can
is
see.
changed.
So not the VMware from here now. I'm using another laptop. Okay. All right. Play virtual machine. Maybe later. Yes. Okay, then I'll log into HT user. So can we see this? Can we see this? Hello, are we still here?
Yes, we can see it.
I will launch this our studio. This guy, I forgot. So I will launch it to go to the. It's launching here. You have this environment. You should have this at your end. Then I believe you should have this.
Emmanuel, sorry. Do you want us to be doing it as you're doing it?
You can do that. You can just follow and do that later. You can
Or just follow you and do later?
either of it.
All right.
Combination with you. So we have like 4 windows. We have like 4 windows there. So let me just give us an overview of what. So this guy here, this first window here, the one at the left top, left is like your editor, where you can edit your code and edit your code. While the one at the bottom left, this console, the command is being run. Any execution you do in your editor here will be run in this area. So and this guy, this window at the top here is your workspace. Whatever command you run is going to be there. All the objects you create, every history kind of page. Like when you're using your Chrome, any website is going to be needed in your history page. You're going to see that where you have your workspace. One at the right bottom is we have like files, keys. So files, browse through the files you have in your current.
Please, hello, Ima. Hello, Ima.
Yes.
I want to confirm if this break is only from my side. I can't. Is it only from my side? Can another participant confirm if they are hearing you clearly?
Hello, Susan and Demilola and Co. Can you guys?
So it says
I have still exactly. There are breaks.
I can hear you.
Demilola, can you hear me? Can you hear me clearly?
I can hear you, but once in a while it ceases.
No. Okay, right is the next one. All right. Can we go on, Dr. Abel?
Yes, sir.
I don't know. So this right bottom here, the files, you see plots. If you make a plot, maybe Instagram or bar chart, you are going to see the results in the plot section. So it's going to be and packages where you can see the different kind of packages into the environment. Then the help and we have the viewer. So just move on to the environment and see what you can do in the environment. So I want to open a new code editor. So how do I go about it? I'll go to File, edit left top. So I click on File, then I'll open a new script. So an empty code here, so I can write whatever codes I want. So where do I start from? I can start from the where I started with the environment. So I might want to see directory I have. You know, in the Linux environment, the code to get the current working directory is pwd. Get this environment, you need to type get wd. Get wd to see the current working environment. Now I did something, but that was very fast. WD with this bracket, then code. And to run the current line the shortcut to do that is faster. So it's actually faster using coming to this guy and click on run. This is current line or selection. You can see control plus enter. So if I click on this, run the line of code of your current line or selection. What do I mean by selection? If I should highlight now and I click on this guy, so it's going to run this code I just selected. So if it is 3 lines of and I click on this, it's going to be 3 from top to bottom. So are we still here? Hello.
Their breaks can't exactly follow. Will it be the system that is switched to?
Okay, I think I know what. Go down, please. How about now? Can you hear me clearly? Can you hear me?
Very well now.
Okay. Okay, let's move on. So this get WD is to get the current working directory R. So to run this line of code, the cursor, I have my cursor on this line. So I'll just press Ctrl Enter to run this current line. Now I might have 3 lines of code I want to run. What I just need is, if I want to run the 3 lines of code at the same time, I'll highlight the in this manner. Then press Ctrl Enter to run those 3 codes. The code is going to run from the top to the bottom. So also, another way to do that is to click on this one. This first one you are seeing here is going to run the current line or selection. But this second one is going to say run the pure code region. That's Ctrl Shift plus. That what this one is going to do is like if your cursor is at this second line and you want to run the code like the previous code, so you can use that. But if you want to run all the line of codes you've written at a time. Like I've written 10 line of codes at a time. I want to run the whole 10. The shortcut is Control Shift Enter. So you're going to run everything at a time. So that is how you do that. Okay.
So I can't see
So
your
when I
screen.
ran
Though.
this, you can't see my screen.
Yes, please.
Who else can't see my screen, please? So what are you seeing, Susan? What are you seeing exactly?
I'm
are you
just
seeing
seeing.
the virtual lab environment? Are you seeing?
I'm not seeing that.
Dr. Abeng, are you seeing the R environment?
Yes, sir.
Susan
fine
can't
now.
see it. So let me.
Yeah, I can now.
Okay, it's back.
Yes.
Okay, okay. So it's the network. Okay, so I use this to get the current working directory. I can also set the working directory, set WD. Then I will specify the path. So I can say /home. I'll put it in quotation mark /home /HD user. Maybe I want to go to desktop. So this line of code is going to set my working directory to desktop if I should run it. So let me try and run that selection. I'll use Control Enter to run this line of code. Oh, cannot change working directory. What's wrong? What? That I cannot set working directory to that part. Hello, is there a break?
There was a break. Oh.
Sorry, I was just trying to. So I was just trying to set working directory from home/hd user to desktop. So it was telling me something. It's supposed to do that, but it's not. It's giving me okay, sorry, I didn't put slash. I think it should now. So let me do this. So I've been able to change the working directory to home/user/desktop. I hope you can see my screen now.
Yes.
So if I want to see whether it has changed, I will just do get WD, then put a bracket. Then you can see I'm on desktop. You can see the output window here, the console area. You can see the output. So after the code, then the output follows. So you can see that it has changed to desktop directory. So I want to go back to dataset directory because I might need to work on some data sets. So let me just let me set the working directory to dataset directory. So set WD to /home/HD user /datasets. This data sets. So I've changed the data sets. So in R is just like Python too, but R is more like a programming language where you write more of codes than compared to Python. You write more of codes in R compared to Python when you're talking about DASCA analysis or data analysis. Because in Python you have functions and methods to do a lot of things compared to how you write more of codes. So there are packages in how you can also work. It's more of writing of codes. Let's see some things you can do. You can do arithmetic operations. You can do a lot of things or what you can do in your Python environment. So if I do 1 + 2, 1 plus 2, for example, you can see the result 3. It's giving me 3. So all those operations, you can do that. You can do logical operator that give us a Boolean result. Like I can say 2 greater than 3. So 2 greater than 4, for example, I should run this code. It's going to give me false as the result. So it's going to tell me this is false. It's not true because 2 is never greater than 4. So you can use the print function to print something. Let's say I want to print hello world now. Hello world. So I'm putting this in quotation mark because it's a string. So that's why I can do that. So print hello world. Then I'll put exclamation mark if I should run this. So it just printed hello world. Now print, and if I should do 1 plus 2, it gives me 3 automatically. But I can also do print 1 plus 2. It's still giving the same result. So any which one you want to use. So let's start with some data structures we have in we have vector, we have matrix, we have lists, we have data frames. How does this data structure work in R? Now vector. Vector, you have 2 kinds. We have column vector. So now vectors can only contain one data type. Say for example, numbers. You have numbers, you have strings and all. So in a vector, I cannot have 2 types of data type. I cannot have an integer and a string in the same vector. So let's see how we can even create vector, for example. So let me say VEC. So how do we assign objects? How do we create variable? We can use equal to, or we can use this less than and hyphen to assign objects, to create variables actually. So I want to create a vector. So how do I do that? I'll use C. C is just like a concatenation kind of function. So I use C to concatenate things together, to put things together. So C, then inside the bracket, then I want to create a vector numbers, say 1 to 5. I can only type 1, 2, 3, 4, and 5, separated by commas. So if I should run this, Control Enter, then it has created successfully. Okay. So if I want to call this vector I just created VAR, okay, it's VAR, I called it. I just need to type VAR and run it. I can also say print VAR, but I can just say VAR. So let's say VAR now. You can see the results 1, 2, 3, 4, 5. Now, I use less than or and a kind of minus sign to create the vector. If I use equal to, there's no crime too. So they usually use this less than or minus sign. Any which one you use. I prefer using equal to anyways, because this one is stress. So let's try. Now you can reuse an object after creating it. VAR is an object. You can reuse an object. So as I already called it VAR. So I can say okay, C is equals to let me say CC. I'm just giving them any kind of name. I can say CC is equal to VAR plus 3. So what is this guy going to do? It's going to add 3 to each element in VAR. So it's going to do like 1 plus 3, 2 plus 3, 3 plus 3, 4 plus 3, 5 plus 3. So I should have something like 4, 5, 6, 7, 8. So let's see. So see, it means this guy has run without an error. If you should see the result like this. So to see what is inside CC, I can just type CC. Then I should run it. So you can see 4, 5, 6, 7, 8. So you just did that. Now, you know I said earlier that vectors can only contain one type of data type. Let's say I can also say VAR. I can use VAR to create another list entirely, another vector entirely. Now, if I should create another vector with the variable name VAR, you know I've used it before. So let me say 1, 2, 3, 4, 5, 6. Now this vector I want to create with VAR, I want to override the one I've created previously. So if I should run this code, now if I should type VAR, it cannot bring this guy I normally created, this 1, 2, 3, 4, 5. It's going to return the recent. So if I should run it, that I have 1, 2, 3, 4, 5, 6. So I cannot use this guy again, since I've renamed it to have another content entirely. So as I mentioned, let's say I want to create a vector that has 2 types of data type. Let's see whether we'll be able to create that. So let me say 1, 2, 3, 4. And I want to put a data type, a string value there. Let's say hello. So this should throw up an error. But let's just going to bring, okay, this came up. Now, so you know what just happened now? Do you know what just happened now? Hello, are you still following me? Is my speaker on? Hello, anybody?
Carry go.
So do you know what just happened now? You know I said you cannot have a vector that have different data types, say number and strings, for example. So what just happened is that it converted the 1, 2, 3, 4 to strings and automatically, because it has contained one string, which is hello. So the only way it can do it is that to convert the other, it can just convert 1, 2, 3, 4 to strings. So 1, 2, 3, 4 in vector VAR we just created is no longer number. They are no longer number, they are now string, because it cannot convert hello to number. So the only way to override that is to convert number to string. So example of that kind of thing is like when they used to give us matrix number. Now your matrix number can look like it's a number, but it's not actually a number, it's a character, it's a string. So you can have that kind of scenario. But there's no way you can say what's hello, you want to make use of hello as a number. So that's what I just did. So since a string is in a vector and a vector cannot contain whether both integer value and string value, the only way you can override that to convert the integer value to string value. So that's what just happened. So it means that if I should do something like AR plus 2 now or plus 3, this should throw up an error because VAR is not an integer value. It does not contain real numbers. So you can see error in VAR plus 3, non-numeric arguments to binary operator. I cannot make arithmetic operation on a string value. So that's why you have an error. So that's by the way. So let's go to creating matrices. So you can also create matrices. So let's say I want to create a matrix. Let me call it MAT. So I will use the matrix function to create a matrix. Then, now, before I go into this, I can create a vector. Let's say I want to create a sequence. The way I created 1, 2, 3, 4, 5 here, instead of me typing 1, 2, 3, 4, 5, I can just create a kind of sequence that will create 1, 2, 3, 4, 5 for me. So what I'll just type is 1, then with a colon, then 5. So this should create a sequence of 1, 2, 3, 4, 5. Let me zoom in. It seems like this screen might be small at your end there. So let me just zoom in so that you'll be able to see the screen proper. So let me zoom in again. So that, okay, I think it's better, So if I should run this code, it should create a sequence 1, 2, 3, 4, 5. So let me call it. You can see we have the same results as when we just typed 1, 2, 3, 4, 5. Okay, so I can also create a sequence whereby it might not follow in this kind of order. Maybe I want to create a sequence 1 to 20 whereby it will skip the next value. So instead of me having 1, 2, 3 up to 20, I'll just have 1, then 3, then 5, then 7. So I can also create such a way that it won't include it will skip the next 2 values. So I can have like 1, then you skip 2 and 3, then you have 4. So what's the function to create that SCQ sequence? So I will say VAR is equals to SCQ. What's going to come up? Where the starting point? Where am I starting from? Okay, I'm starting from 1. Okay, where should it end? Okay, I want it to end at 20. Okay, what's the how do I put it? Okay, how many numbers should it skip? Is it just 1 or 2? If I put 1, it's just going to list 1 to 20. It's just going to list 1 to 20. If I should put 1, I have to put 2. Tell me that skip the next value and go to the other one. So I'll put 2 there. So it means this should print 1, 3, 5, 7 in that order to 19. So let's see the result. So you can see 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. Okay, good. That's by the way. Also, we can also create a sequence of letters. Now, how as a way to create sequence of letters, they have already created it in terms of a function. So you can create a sequence of letters in lowercase or uppercase. So what would I use? So what would I use? I would just use the function letter. So if I want it in lowercase, I will type lowercase and letter in lowercase. If I want it in uppercase, I will type letter in uppercase. So let's see how that will work. So letter, so it's in lowercase letters. Then if I should put 1, then colon, then 20, 10 rather. So this should give me the first 10 letters in lowercase. So let's see how this is going to work through. Oh, could not find the function letters. No. Sorry. I don't know why I have that. Sorry, not this. I'm not supposed to. I think I'm not supposed to use this. So let's do this again. So this is it. So I think there's a misconception there. The letters is not a function. It's a list. It's kind of a list that has been created in R already. So they just created a list of alphabets in uppercase, a list of alphabets in lowercase. So what this guy just did, like I put in brackets, then just like I indexed it, I called because lists are indexed. So if I say letters now, if I should say letters, then in square brackets, I put 1 there. So it's going to call the first letter. If I should put 2, it's going to call the second letter. So let's see. This should return B in uppercase. So you can see this. So it's like they are indexed. So if I should type just letters, if I just type ordinary letters and run it, so it's like a variable that is created in R already. So this should return A to Z. A to Z. So you can see it's created a list of letters in uppercase A to Z. So this guy that I wrote here, letter 1, then colon 10 in square bracket, is just telling me to return letters from the first letter to the 10th letter. That's A to J. So that's what this guy is doing, is indexing. So the way you can index in list, you can also index a vector. So let's see, for example, the vector we created that is 1 to 5, VAR. Let me create it to be 1 to 10 instead. Let me call it. Okay, we have 1, 3, 5, 7, 9, and 11. Suppose I want to see the first 5. I want to see the first 5 letters. I can use this VAR. Then I can use this square bracket also. I should be able to use that. Then colon, then 5. So I'm expecting this to return the first 5 elements in VAR. So this should be able to return it. So this concept will really help us a lot before we enter data print. I hope we have a lot of time. So to this point, I hope you understand what I've been doing to this point.
Iman?
Yes, sir.
My question is, when we did the VAR 1 to 5, and then we did VAR
Okay.
1 to 6.
Okay.
Then the new VAR of 1 to 6 overwrote the VAR 1 to 5.
Exactly.
So now, if you want to keep those two variables or those two vectors, does it that you have to rename them?
Yes, exactly. You have to rename them. So you can call this one VAR1 and call the second one VAR2.
Then you can retain the first one.
Yes, so one object cannot carry two outputs at the same time. So I will also tell us something. Any vector you create here, any object you create here, like this VAR as I'm creating it, is a global variable. It's a global variable. So we have global variable, we have local variable. We are going to see that as a proceed. I don't know. We're going to see that as a proceed. So global variable are kind of variable you can use anywhere. And local variable in an instance. So if you create a function and you created a variable inside that function is called a local variable. So the function inside a function, you can't use them outside the function. Am I making sense at all?
Yes.
So those ones are local variable. Okay. So let's move. Before I move on, I might want to do something. Okay. Let's say this VAR I just created, which is 13579. Maybe I want to make the first entry, which is 1. I want to make it 21. I want to change it to 21. I think I'll be able to do that with this syntax. VAR1, that is the first, I'm saying that the first entry in VAR is equals to 21. So this should change the first entry in VAR to 21. So let's see how that is going to go. Okay, so let's now see what is inside VAR now. You can see that the first one has changed to 21. Can we see that?
Mm-hmm.
Okay, now we are going to move to matrix now. So just please give me 3 or 5 minutes. I want to use the restroom. Please permit me.
You can close from there, no problem.
No, you cannot close. No, you cannot close. All right. Can we move on now?
Yes, we can.
Okay. Hello, Susan. Are you still with us?
Yes, I am.
Okay. So we want to go to vectors now. I want to go to vectors. So let me vectors. So what I just did now, I just like this is like commenting. I'm commenting. I'm commenting. If I should run this code, it will not run. It will not run. It's just it's like a comment. So sorry, we want to enter matrix, not vectors. So let me just matrices. Okay. So let's say we want to create a matrix MAT, then equal to, then what is going to follow is matrix, like one matrix. Then if I put it in the brackets, automatically it's going to show you something. All these things is going to show you all this guy. It's going to show you. So this first entry saying data is equal to. So if you have a data you want to create a matrix from, so you want to create it from a data or you want to just create it manually. So let me say I want to create a matrix with a sequence, say 1 to 20. So you know how we create a sequence now, 1 to 20. So I'll just write 1, then colon 20. So this is the data I want to put. Okay, you know it's a matrix, and the size of a matrix is the number of rows times number of columns. So it means that if you are specifying number of rows, you should match number of columns. So your second argument should be the number of rows. So let's say my number of rows, I want it to be 5. Your third argument should be number of columns. Okay, I want it to be 4. So it must match up with the size of what you have. So it doesn't match up, you will see what it's going to do. So let's create a match. Then the next thing you have to specify is whether by row. So by default, by row is false by default. But if you want to make it to be true, you have to put this. By row is equal to true. So what do I mean by this? It means that, you know, if you create a vector 1 to 20, now by row equals to true is that, you know, we have 5 rows. So it means that it's going to make 1 to 5 the first row, then 6 to 10 the second row, then 11 to 15 the third row, then what again? Then 16 to 20 the fourth row. But I said the number of rows is 5, so you cannot pick it that way. So it's going to be 1 to 4, then 6 to 9 in that manner to create 5 rows. So that's how it's going to pick it. But if I shouldn't specify by row equals to true, normally it's going to take it as false. So it's going to do it by column instead of row. So if I want to give the dimension a name, so what do I mean by that? I want to give the column a name, and I want to give the row a name. So row 1 will have a particular name. So I'll use this syntax, this dim names. So I'll type dim names. Then your dim names is going to be a list. So automatically, how do you create a list? You use the list function. Then I'll now put it inside the list. The first vector is going to be the one for the row, and the second vector should be the one for the column. So let me say the one for the row, I want to call it R1. So it's a row name, so you put it in quotation mark R1. So since we have 5 rows, so I'll say R1 to R5, R2, sorry, R2, comma.
No, will the color not work in this side, in this aspect, where we say R1 column R5?
Oh, it's going to work. It's going to work. So just first create the
Okay.
matches. You see how to
Okay.
index that.
Okay.
So R3, comma R4, comma R5. Then you create a list for the column 2. So let's go down C1, C4. So we have 4 columns. C1, comma C2, comma C3, comma C4. So I think that's all you need to do. Then you click on Control Enter. So we have created a matrix of 1 to 20, which has 5 rows and 4 columns. So let's see the matrix MAC. You can see this. So does it make sense to us like this? Does this make sense? So you can see the name C1 for column 1, C2 for column 2, C3 for column 3. Someone wants to say something, sir?
You had to type maths again before the matrix could come up.
Yes, because I
thought immediately you enter, it will just go.
No, the matrix I created, I assigned it to an object. So I have to call the object to show the matrix. I didn't put this, I didn't create this object. I just type matrix, blah blah blah. It's going to show me the matrix.
Okay.
Yes, exactly. So another way you can create this. Now, sometimes you might not know whether it is the number of rows you specify first or the number of columns you specify first. So instead of me to put 5 and 4 here, I'll just say n row. I'll say n row is equals to 5, comma n col is equals to 4. So it's going to tell me that. So it's going to know that the number of rows you want to specify is 5 and number of columns is
5 by 4 column. Okay.
So another way you can specify it is that. So it's because I already know that the second entry is the number of rows and the third entry is the number of columns. That's why I can do this. So you can see that it took it by it took the 1 to 20 by row, 1 to 3, 4, first row, 5 to 8, second row. But if you just specify that by row is equals to true, then what it's going to do is going to do it by column. So you are going to have 1 to 5. Then you have 6 to 10. You have 11 to. That's what it's going to do. You understand? Do you understand?
Yeah.
Okay, so let's see how we can index with matrix. Now you can index with their position, or you can index with their column or row name. So that's if you give it a name. So let's say I want to call elements in row 1, column 1. So this is what I will just do. I'll MAT, then I'll put a square bracket. So it's mostly square bracket they use to index. So I will type, okay, row 1, comma 1, that is elements in row 1, column 1. So this should return 1, right?
Yes.
Okay. So you can see that we have 1 here. Okay, suppose I need to index out the whole of row 1. I need to index out the whole of row 1. So I just type 1, comma, then I'll not put anything in the second index. So I won't put anything in the second index. I'll just type 1. It means give me 1. So if this second index is empty, it means return all the columns. So it means it gave me 1, 2, 3, 4, which is row 1. Okay, I'm interested in that. I need column 3, for example. I need column 3, the whole of column 3. So I won't specify anything in the first index, then I'll put 3 here. So this is going to return everything in column 3. You can see, this is everything in column 3. 3, 7, 11, 15, 19. Okay. I might also be interested in, I want to see everything in row 3. I want to see everything in row 3. I'm going to M80. Sorry. I want to see everything from row 1 to row 3. So I'll say the first index is going to be 1, then colon, then 3. So it means 1 to 3. Then I'll put comma, then I'll not put anything in the colon. It means return row 1 to row 3, including all the columns. So this gives me row 1 to row 3, including all the columns. Now, in another scenario, you might not want it to return all the columns. Okay, I just want return row 1 to row 3 for just column 1 and column 2. So I can do this. So let me just copy this and put it here. And I say, okay, row 1 to row 3, then just return column 1 to 2. So we can see this now. So I have not done something. So, but I want someone to give us an idea of how to go about it. So suppose I want to find elements in row 1 and row 3 and row 2 and row 4. So row 1 and row 3, then column 2 and column 4. So return all the elements in row 1 and row 3 is column 2 and column 4. That corresponds to column 2 and column 4. Who can give us an idea on how to go about that? I hope we got my question.
Just come again, please.
So I want to find the element. So let me go back. Let me scroll to that guy, to this matrix we created. So I want elements in row 1 and row 3 that corresponds with column 2 and column 4. So I want you to return 2, 4, 10, 12. That's what I want. So do you understand what I want now?
You want the element in column 1?
Yes. No, row 1 and row 3.
Row 1 and 3.
That corresponds with column 2 and 4. So that's the return elements 2, 4, 10, 12.
Is mad 1 column 1 to 3?
So
1
just
column 3 mad.
So tell me why I'm going to type it.
MAT.
Yes.
Bracket 1 column 3.
1, 3. Is it 1, 3?
Comma 3 is 1 to 3. No, it's 1 and 3. Yes. No. 3.
1, is it 1, 3?
Yes.
Okay.
Then comma.
Okay.
1 comma 3 again, because the columns are 1 and 3.
No, 2 and 4. 2 and 4.
Okay, 2 and 4. 2.
So that's 2, 4.
Yes. Am I right?
I don't know if you are right.
Oh yeah.
As we run it,
I try. Let's see. Will it run?
Is there incorrect number of dimensions? It was an error.
Oh. So what? Okay, there's supposed to be a colon after 3. 1, 3 colon 1.
Colon Abi. Okay.
Yeah. 1, 3 colon 2, 4.
Okay, like this, Abi.
Then remove the column. Will it run?
Okay. Error, incorrect number of dimensions.
Oh. Okay. I'm waiting. Maybe, I don't know. We are taking row 1 and row 3.
Yes.
Column 2 and column 4.
Yes. So anybody that has an idea again? Susan, are you still there?
I'm still
3.
So do you have an idea for us how to get the job done?
Or could it be a column in between?
No, I don't think so.
I don't think so, because if you put colon, it is going to run 1, 2, 3.
Yes, exactly.
So we're
I don't want
taking one.
I don't want this. I don't want it to run 1, 2, 3. I just want it to return
1 and 3.
Yes.
Then does it accept semicolon?
Yes, sure.
Maybe semicolon should take the place of colon.
So semicolon needs to work. Let's try it. Let me put semicolon here. If you get what you're saying, then I'll put a comma here. Then put a
semicolon after 3.
Oh, okay. You mean semicolon after 3?
No. Yes.
I be like this. Is it like this?
No. 1, 3, semicolon.
1, semicolon, 2, 4.
1, remove the semicolon there. Okay, good.
Okay,
yes.
Like this, okay.
Yes.
So
Let's see.
It doesn't work. Unexpected. So you say unexpected symbol, like the semicolon is not supposed to be there. It's not supposed to be there.
Okay.
Anybody
So I give up to the class.
Okay, can we try this? Math
okay.
1.3.
1.3, that's full stop.
Yeah.
Okay.
Column 2.4.
Column 2.4. So let's see how it's going to work. This one return 1 and 5.
5.
So let's see how that return 1 and 5. Let's see how that return 1 and 5. Let's see. So 1 and 5. So it's 1 and 5. So return 1.
Column 1, row 1 and 2.
Column 1, row 1, column 2, row 1.
So, Emmanuel.
Yes.
Does the environment accept and as a sign?
Yes. It's attempt like the and sign. This sign, Abi. Let me type.
That's
this sign, Abi.
Yeah. Yes.
Yes, I think it does.
Okay. So let me go for a second try.
Okay.
So
it won't pick it.
1 and 3.
1 and 3, Abi.
Yeah.
Then
and 2 and 4. Column 2 and 4.
Column 2 and 4. Okay. So let's try that. This is what return do.
Yeah.
So I think let's do this. Instead of this column, let's put a comma there.
Oh,
okay.
Yeah, comma, sorry. I wanted to say comma, sorry.
So this is what it returned. It returned everything.
It returned the whole matrix.
Oh yeah, save us from our blushes, Emmanuel.
So I want Susan first to talk now. I want Susan to talk now, but Susan is not talking. Hello, Susan.
Susan is cooking.
I'm with you. Sorry.
Susan is cooking.
So we want 1, 2, 4, 6, 8, right?
2, 4. Let me see again. Yes, 2, 4, 10, 12. No, 2, 4, 10, 12.
2, 4, 10, 12. 2, 4, 10, 12.
It's the last thing on this 4.
Yeah, 2, 4, 10, 12.
So we have 2 column 4. I'm right.
How should I type it?
I'm trying to figure it out, sorry.
Okay, without wasting much of our time, let's Let's try this out. Let's try this out. Me too. I don't know. I just want to try it out. So I think it's better we should put it as a vector. Our rows is a vector. So I'll put this guy. I'll now type 1,3. Then put this one and type 2,4. Do you understand what I mean?
Yeah.
Are you not going to put hyphen after the 1 and 3?
No, it's not. It's comma that will be there.
It's comma, okay.
Yes. So this C into 1,3 is saying that, okay, it's creating a vector 1,3 as their row. So it's saying that row is row 1 and row 3. Then comma, then you specify your column, which is vector, which is 2 and 4. So let's see whether that's going to work out. So did that work out?
Yeah, we did.
Is that what we want?
That's what we want.
That is what you want.
Okay, what do you want, sir? What do you want, sir?
No, we don't want anything. We're following you.
That's what I want to. Okay. You can also, make alterations to your vector, to your matrix rather. So I can change the elements in row 1,1 to be something else entirely. So I can say, okay, mat, the old elements in row 1, I want it to be multiplied by 5. So I want the whole element in row 1 to be multiplied by 5. So I say M80, sorry, this is not correct. M80 element in row 1 is equals to M80 element in row 1 times 5. So this is going to multiply everything in row 1 by 5 and return and put it in row 1. So let me run this. So if I should call M80 now, you see that all the elements in row 1 has been multiplied by 5. You can see that has been altered. Now, you have been indexing our matrix with numbers. We can also index it with the column and vector column names or row names. I want to call it with, okay, I can say R1, comma, then don't specify anything. You should return everything in row 1. So you can see this. So I can index it by their row name too. So in case of this one that we typed here, if I want to call column 1 and row 1, row 3, and column 2, column 4. So what I'll just replace here is I'll replace 1 with the row name, which is R1. I'll replace this with its row name, which is R3. Then I'll replace this with its column, which is C2. Then come and replace this with the column name, which is C4. So virtually, let's just say virtually. So in reality, they don't really index with position. Index is the column name. Now, if you are working with data frames now, if you are working with tables, so you might not necessarily know the position of where a particular column falls in. We just know it by name, so we just by name instead of by position. So you might not know the position. So your data can be so large whereby you cannot even see the column in extreme end. So you just know that, okay, the column name is age. You just call it by the column name rather than calling it with the index. But then if you know the index too, it saves you the stress of typing. So that's one thing again. So do we get that? Hello? I want to find out what are the row names of this matrix. I can just type this command. So you can see that it gave me the row name of this M80. Okay, I might be interested in, okay, I want to know the column names. I can just type this, column names of maths. Then it give me this. So are we on the same page?
We are following.
So that is that about matrices. And don't forget, matrices can only take in data types of the same type. So I can only put integers, only integers, or only characters and the like. So I want to do something. I don't know whether it's going to work. So you know, I created a vector VAR that time. Let me call it again. VAR. So let me see. I want to let me create a vector that has just 5. Let me see, 4 elements. So vector 1 to 4. So I want to see whether I can add this with the matrices I just created. So I want to add the matrix and the vector. Let's see whether this is going to work out. So did you see what just happened now? Did you see what just happened now?
How is the addition done?
So the addition is done row wise. So so let me call the VAR. Let me call the VAR vector for you. No, sorry, the MAT. Let me call the MAT matrix for you. So you know the VAR vector is 1, 2, 3, 4. So
yes,
one is added to row 1, column 1
to 5.
Give us, yes. So
to give us 6.
So added to 10 to give us 12.
Okay, 3 is added to 15.
Give us 18.
Okay.
4 is added to 16. 4 is added to, sorry. 4 is added to, what is it? 4 is added to 20 to give us 24. So in that, so like, component wise.
Okay.
So I want to try and do something. I want to create a vector that the element is more than the number of columns we have. So you know that in this case, I created 1 to 5.
Will
so
it not return errors?
So we want to confirm that. So if you have issues adding up 5, so let's see what is going to return. Now it gave us this. It gave us this. It gave us this. So what really happened? Let's understand what really happened. Now in this case, what did it do? Instead of adding row wise, you now added column wise. Did you get what
Is it because the columns are less than the rows?
No, it's because we have 5 rows here. So the way it's going to add it is going to add it based on the 5 elements we have here. So instead of adding it in terms of the columns, adding in terms of the rows, it's adding in terms of columns. Because the number of elements you have in each column is 5. Do you understand? So now, I want to create a vector that has 6 elements. So let's see what's going to happen then.
Why not we try less element? Like we have 5 now. Let's take 3.
And let me first try this of 6. So let's see.
Okay.
So let's practicalize it.
Okay.
So I've not tried that. Just came to mind. So let me just try something like this. So you can see it gave us an error. Longer object length is not a multiple of shorter object length. Okay. So this means that it's actually added. It's actually added, but it gave us a warning. It gave us a warning. So let's see what happened. 6, 7, 16. What happened here? All this one 22, 22, 22, 12, 12, 12. So let's see what happened. Okay. Okay. I think I get what happened. This is what happened. You know, we created object length 1 to 6.
Yeah.
So 1 is added to 6 to give us what am I saying? Where is the original vector? Let me call the original vector.
Am I still there? I don't know what has happened to Iman Susan. I thought I'm the only one that is involved.
No, I think he has. I don't know. I think he has left. Maybe network issues.
Maybe. Let's hold on. Almost there.
Yeah.
Wait, can you get?
Are you back?
Yes, yes. My network went up.
Okay.
My network just went off.
Okay.
Let me share my screen again. The battery just went down. I didn't know that the battery is gone. I had to charge it. Okay. Can you guys see my environment now?
Yep.
So what actually happened? It gave a warning, but it actually added the matrix. So I want to explain how it's added the matrix. It's added the matrix column wise. So, but we're going to see what actually happened. So from here, it's added, this is the original matrix. So we are adding the vector 1 to 6 to it. So it's added 1 to the first one element here, which is 5, to give us 6 here. Added 2 to give us 7. Added 3 to give us 12. Added 4 to 13 to give us 17. Then 5 to 17 to give us 22. Now it now went to 6 to go and add it here. So it now added 6 here to 10 to give us 16. They will now come back to 1 Then like that,
Yes.
1, 2, 3,
Yes.
4, 5, 6. Then 1, 2, 3, 4, 5, 6. Then 1, 2. So it was adding it like that. So let's see.
Imam,
Yes, sir.
if we reduce it to 3, the same process
Yes.
is going to happen. If you add 1 to 3, start 1, 2, then go back to 1, just continue. That's the same process that is going to happen if we have less.
So yes, exactly. That's what's going to happen. So yes, one more thing I want to do. I want to create a matrix whereby the size of the matrix does not match the vector we created. So this is what I'm saying. Let me create a matrix 6, for example, or 1 to 5. Yes, 1 to 5, or 1 to 4. So I want to say, okay, the number of row is 3, and the number of column is 2. So let me say by row is equal to by row is true. By row, you know the size now. The size of the matrix is 6, but the element I'm creating is 4 elements. So what's going to happen to the remaining 2 elements? So what's going to He gave a warning. He said that data length is of 4, but it's not a submultiple or multiple of the number of rows and of 2, 3, or whatever. So let's see what's going to happen. What's going to be the result? Now you can see what is created. Now you know it's by row. So 1, 2, the first 2, then 3, 4. It has exhausted the element I have. So now I went back to 1, 2 again.
Exactly.
So that explains that explains matrices. So let's go to list now. Let's go to list. So I want to create a list. Let me call it my list. So when do we actually use the list? So you can use list when you want to some things in depending on the attributes. So okay, maybe I want to create a list of foods, and a list of clubs, a list of countries, a list of numbers, and all that. So you use the function list to create it. So let me say, I don't know. Let me say create foods is equals to, then I have banana, I have apple, then I have orange, then I'll put comma. I can put comma. So let me see. I want to create. I want to see whether this is going to work out. So let me create. I want to create a list of integers. Integers, just 1 to 10. Or vector. So let me call it VS. Let me call it VAR. VAR. So I want to create a list of matrices. So what I'm just doing is that I'm putting the object I've created already inside the list. This is what I'm doing. You know, I've created an object, a vector VAR, and I've created the matrix. So I'm putting them inside the list. Same way, I want to create a list of country, which is equals to let's say Nigeria, let's say Ghana, and let's say Togo, let's say China or Mali. Then I want to create letters. Letters is already an object that is created in R already. So let's see how this is going to. So this has created already. So let's see what's inside my list. So can we see this? Can we see this? Hello. So the first one is fruits. I gave it a name, which is banana, apple, and orange. The second one is an object that I already created. That's VAR. What's inside VAR? 1 to 6. You know, that's the last time we created it. Created 1 to 6. Then the second one is the MAT object.
The last matrix.
Yes, the last matrix we created that repeated itself. Then the country I created. Then the object letters that's already inbuilt in R, which is A, B, C, D. So it's called it according to the name I gave it. You know, it didn't give this one a name because I didn't actually give it a name like that. I just called it. So let me go back and give it a name. Let's say VAR is equal to VAR. Let's say MAT is equal to MAT. Then, so I'm editing the code now. I want to edit it down. So let me say LET is equal to letter. LET is equal to letter. So let me run it and call it again. So okay, you can see now that okay, fruit is this, okay, VAR is this, MAT is this, country is this one, then letter. The way you created this letter is very funny. It gave it let 1, let 2. So that's how what do you call it? That's how list works. The way you can index matrices and what do you call it? Matrices and vectors. You can also index lists like that. So let's see how that works. My underscore. Then I want to call the first element. Now the first element is what? Banana. Sorry, what I'm saying? Fruit. That's the first content that's inside. Have you now? Hello.
I'm with you.
So this is going to return fruits, everything. So, but suppose I want to call fruits, but I want to call the first element. So it's like I want to index inside a particular index. So I'm not calling only fruit, but I want to call the first element inside fruit. So I should put another square bracket and 1. So this guy should return the result I want. Do you understand what I'm saying? Are we still there?
Oh yeah.
Do you understand what I'm trying to do?
I'm trying to.
So first of all, let me erase this.
Okay.
So this is calling fruits. This one is going to call fruits. You can see this is the first element in the list.
Okay.
But fruits is a vector. Abina is a vector we created inside the list. So I want to call. I'm not only calling fruits, but I want to call the first element inside fruits.
First element inside fruits.
This guy is calling fruits. But to call the first, that's banana. So to call the first element inside fruits, I'll put another square bracket and call the first element. Then put 1 here. So this one is saying call the first element inside fruit.
Okay.
So do you understand the index now?
Mm-hmm.
So if I should go on this should return banana. Let's see. No, it didn't work. It didn't work out that way. It didn't work out that way. I think.
Don't you think there should be double bracket?
I actually wanted to call double bracket. Let me see. Okay, like this.
something there. Okay.
So let's see.
No.
It didn't work that way. It didn't work that way. Let me see something like. I'm not getting something there. Oh, there's a way. No. Okay, this works. This works.
Okay.
Okay, this works. I might want to see the first two elements. That's I would just this and two. I think comma should also work here. I'm not sure. The comma shouldn't work unless I'm going to concatenate it. So if I want to see the first and the third, I can just put this concatenation 1,3, which is banana and orange. So that works well. That works well. So I'm also say inside the matrix we created, I can also index inside the matrix too. So it's just the idea. Just the idea. I believe we got the idea now.
That is it. We have.
Is that?
On my part, I'm trying to get the idea. Like I said, if not
okay,
that
okay, I'm going to get it. So,
if not that the general maths helps us, these things are new, but we are trying to catch up very fast.
okay. So I want to do another thing. I want to use like I want to use a comparison. I want to do a comparison kind of operation on this. So let me call the math I created the other time. So let me just use this matrix. So let me run this so that I'll be able to use this guy. So I want to perform one operation for me. So now what I want to do now is that now, okay, I want to select all the elements in row 1 and row 2, including all the columns, but I want to just numbers in row 1 that is greater than 2, or row 1 and row 2 that is greater than 2. So I will explain what I mean by that. So I want to do something like this. Something like this. So I'll do a kind of index. Which math. I know this might be going some kind of is going some kind of deep, greater than 2,3. This isn't work. Sorry. Or let me say in column 3. It didn't return anything. So before I dive into this thing, so that I won't be confusing you guys. So let me just.
That's what, in fact, you just spoke my mind.
I won't just be confusing you guys. So let me just go to another thing entirely. So I've talked about this. So that I want to end up at vector data frames now. So let's go to data frames. Now let me call the math function again. So I might want to convert this guy to data frame. Now data frame is just like an Excel format kind of data, a spreadsheet, tables, something like that. So you can think of it like that. So in the data frame, each columns can only take a single type of data. So if I have column 1, so what's inside column 1 is integer, it will be integer all through. If not string, it will be string. But you guys know how columns work in data frame in Excel. So I can only in one column can only be maybe integer, maybe date, maybe character. So that's how it's. So I might want to convert. I might want to convert. So let me write data frames here so that I know I'm talking about data frame. I can convert a matrix to a data frame. So how do I do that? Dot math is equal to, so let me first give the variable. Let me say df is equal to data dot frame. This is the function to call the data frame. Then what do I want to call to convert to a data frame? So math is the math matrix. So M8C. So let's see how this goes. So let me call df now. So this is now a data frame. This is now a data frame. It's no longer a matrix now. So it's no longer a matrix now. So if I say, if I want to check whether the class of the object I just created, I'll just type class, then put df. You can see the class is data.frame. So if I want to check the class of a M8C is, if I should run the system that's a matrix, you can see that is a matrix. So if I want to check the class of the list I created, that's my underscore list. So tell him it's a list. So what we just, the df we just created is this is a data frame. This is a data frame. So I want to check something. So hold on. So there's something I want to do. So let me just repeat this. Do you know what I want to do? Do you know what I want to do? Hello, are you still here?
I'm with you.
I don't want it to bring these row names. I don't want to bring these row names. I don't want it to bring these row names. So I want to remove these row names R1, R2, R3, R.4 something. It should work is row.names. Row.names equals null. Maybe this should work. So let me just run this and see. So if I should call the df function, it has removed the row names. So I just have it indexed normally. So I just have it indexed normally. Do you understand what I just did?
Mm-hmm.
Okay. So that's how a data frame works. So a data frame.
So sorry, if you want to remove the column names, you repeat the same, say column names, no.
Yes. So let's try that. Okay. Let's try that. So I've
we can just add that. Let's just add that.
So you can see it has returned to the normal df we have before.
Okay.
So let me just put comma. Sorry, colon. That'll be colon. What should be? This one is row.names. So
column
this one should be what?
Column names.
What do you think is going to be?
Column names.
Is it COL? Just let me type.
Yeah,
let me type now.
COLNAM. NAMES.
Do you think it's going to, so, you know, I wrote row dot names here, so it's supposed to be like column dot names. What do you think? Is it supposed to be so? Column dot names? Compared to what I just typed here.
This column dot names, is it what you invented, or that's what the system recognizes?
So that's what the system, this go dot names, that's what the system recognizes for data frame.
Column dot names.
Yes.
Okay.
So I'll still try one more thing, but let's see how this one works. I want to see whether this is going to work. So it's saying that error in data.frame, blah, blah, blah. Argument depend different number of. I don't know what it's saying. Let me see what it's going to have. It does not. It doesn't make any changes. Let me do this. So you cannot use arguments. You cannot use this argument. Let me test this argument. Go names. But let me, instead of null, let me see whether null is going to work. So if that doesn't work, let me use false instead of null. Go names equals false. Okay. Okay, so let me see this. Oh, we just created another column entirely. So that's not what we want. So you just go dot names equals false. Go dot names equals null. Now you can change, if you want to see the names of your column of the data frame. You know, that's majorly what is important in of data. You are only interested in the column names. They don't usually use column names. So to find that, you are going to use this command, names, then the data frame you want to see the column names of, which is df. So if I should run this, you should give me the column names, which is C1, C2, C3, C4. Did you see that? Hello, are we still following?
Yeah.
So I might be interested in changing the column names. So I'll just say columns names of df is equals to, and I'll create a vector having the names. Since I have four columns, I'll now specify, okay, let this one be called 1, then called 2, comma, called 3, comma, or 4. So this should rename our column to these names. So I've entered. So let me call the data frame df. The column names have been renamed to the specific columns you gave it. So that is that about data frame. We can also index in data frame. It just follow the same logic as how we have been indexing. So I might be interested in seeing column 1, 3, and I want to see every columns. So I'll say df, then include in brackets 1, column 3. That's 1 to 3. Then if I want to see all the columns, I'll just put a comma, then I'll not specify anything. So that we return all the columns and go 1 to 3. So you can see that works. Now another kind of function that is interesting in this is the head and the tail function. So what do you use head and tail to do? Head should return the first 5 rows of the data frame. So this, you can see it returns the first 5 rows of data frame, 1 to 5. Even though the data frame just has 5 rows, but by default it should return 1 to 5. But if you want to specify the number of rows it should return, I think you should just put comma and specify the number of rows. So I want it to return 3 rows. I think this should return the first 3 rows. As you can see. Also, if you're interested in the last rows, I'll use tail instead of head, then df. Maybe I'm interested in the last 3 rows, I'll just put 3 here. then you have the last 3 rows. Are we together?
Yep.
So in data frame, you can also get the summary. So the summary is going to give us the 5-number summary, then the mean will be included. The 5-number summary is the minimum, the first quartile, the second quartile, which is the median, the third quartile, which is the 75 percentile, and the maximum. Then it's going to include the mean, which is going to end the summary. So if I choose summary, then DF, so that should work. Oh, that didn't work. Could not find. Oh, sorry, I didn't type it very well. It's supposed to be one single R, not double R. So summary. Column 1, the minimum value is 1, the maximum value is 17, the first quarter is 5, the median is 9, the mean is 9, the third quarter is 13. So it did that for all the columns. So this will be the end of today's class. So in our next class, we look forward to moving on to some other interesting things. So we have been introduced to all the data structures, kind of data structures we have in R. So I hope this really went a long way. Also. Hello, Dr. Abing, are you still with us?
Yes, thank you, Marco. It went a long way.
Temnola, you are still with us. Wow. Dr. Abing, are you still on the call?
Thank you.
So still on the call. Dr. Abing is still on the call. All right, Susan. So how was today's class? Susan?
That's good. Good. I learned some things.
So I didn't hear that.
That was good. I learned quite a number of stuff today.
Oh, okay.
Can you hear me?
To follow up as I was doing? Yes. Were you able to follow up as I was doing it, or you just practice them later?
No, I'll do it later. I followed you.
All right. Okay.
I'll do it later. Yes.
No problem. I think Dr. Abing.
I was not hearing you.
Okay. Oh, sorry. I was saying that was the class. That was this class too.
I'll go up to that point. So what's next?
So in our next class, we go deeper in how we can use this data to perform some graph representation and do some great functions and all that. So it's more. Okay. All right. The recordings will be provided later in the wheelchair. I'll provide the link. You guys were able to access the previous class.
Yes. Thank you very much for that. It was very great. It was very great, and this is going to help us. I will talk with you personally after the class. I hate to tell you this, my VMware again did the same issue. I'm not even interested again in that thing. They're giving me too much trouble.
It's because probably, it came up the other time, maybe the way you wanted to shut it down or something.
As in that day we finished it now, I didn't put it on. I did not touch it. I just put it on this afternoon as we're doing that thing. You see, ran blank again as it was. So I'm really not interested again. It's not that it's necessary that I have.
So I think you just remember the process we went through the other day. Maybe later we'll talk about this.
Not later. You can't be today again. Please go arrest. If at all, it will be next week.
I still have another class by 3 to 6.
Okay, that will be next week. We don't do that.
All right. Bye for now.
Thank you. Susan, thank you. Bye.
Bye, Dr.
Okay, at least today I can hear your voice. Last week we didn't.
Yeah, but everything's sorted out now. Right.
Your voice.